My principal belief is that the people who aren't getting vaxxed are just fucking afraid of needles. They need to get over themselves. Stop being such a baby. It's just a shot. There's nothing to it. But because of this shit, everybody's summer plans are gonna end up being bullshit. We're all gonna be stuck indoors again. More scared of needles than he is of COVID. That's just not, like, I have no sympathy. You know, like, a jab in the arm is nothing compared to lung failure, you know? Like how uncomfortable are you gonna be when they jab a tube down your throat? How about that? I don't know. I'm somebody who, from a very early age, is not allowed to be squeamish around needles. There are no excuses for me. I would be dead. And my belief, and I have to call it a belief, because it's not like I've done any research or surveys or anything. My belief is that most of these people who aren't getting vaccinated are making up elaborate excuses for why they don't want to get stuck with a needle, because they don't like needles, and people will do almost anything to justify something they're afraid of. It really ticks me off. It really just gets me fucking steamed. Because it's literally dangerous for them to be like that. Basic immunotherapy withstanding.
Just kidding. And thanks for the gift sub to Silly Disco earlier as well.
Good to get a national night out and a few masks with friends or huggers. This is why we can't have nice things. Yeah, I've started wearing a mask again. I'm scared of a needle, but I took the COVID jab with a big smile. Hell fucking yeah. And that's what it's all about right there. Because it's not just about you, you know? Done everything I can. There was a thing on NPR. This is why I'm so hot under the collar about this right now. There's a thing on NPR with psychologists talking about how to approach somebody who will not get the vaccine. And one of the things to do is to figure out what the barriers are. You know, not just ask them, why won't you do this simple thing? It's what's preventing you from doing this simple thing. But oh man, I'm just angry. Thinking about getting a shirt that says fully vaccinated because I'm not stupid. Yeah, I know. It's a little annoying. Got my second today. Hell yeah, Mako. How many hours in are you? You'll probably feel a little tired. I'm not wearing a mask because of those idiots. I don't know, man. Philadelphia just instated a mask mandate. I'm not looking to violate it. I'm gonna wear a mask because I'm fed up, you know? It's like I'm fed up and I'm angry, and they kind of reap what they sow at some point, you know? But I don't know, I'll do it. It's fine. It's a fucking piece of cloth, it doesn't matter. Means I don't have to smile. I gotta clean this up. I don't even know what to do with all this stuff over here. All right, this is sent in by the other Lone Star, by the way. Got my second a week ago. Lymph nodes are still sore? That's a strong reaction. Man. That means they're working though, right? You see, or somebody kept pushing misleading stats. Counted a whole bunch of hospitalizations and death back in the winter wave. Before most people had a chance to get vaccinated. Seem to have screwed with their numbers. I don't know, man. Okay, apparently Florida is like a fucking hot zone. To almost nobody's surprise. I'm just disappointed in this country for letting misinformation rule their lives while spouting the exact opposite. You know? It's so counterproductive. It's like weaponized stupidity, and somehow if we could harness that to create electricity, we wouldn't need more power plants in this country. We'd be able to power the whole world with the amount of weaponized stupidity that we have access to in this country. I'm sick of sugarcoating anything about, you know, COVID or the vaccine. You know, you're not going to get a vaccine? Have fun fucking dying. And I pity the fact that you're putting a burden on the entire system because you're stupid. You know? Like, wow, that's pretty strong, oh bother. Yeah, that's about where we're at right now. I'm sick of hearing about this shit. We should have been done with this. We did everything in our power to be done with this. Anyway, the other Lone Star sent this thing in. It is a digital recorder for SSDs, and it's a little rack mount device that is completely fucked. There's something wrong with this, so I want to look at this on Friday. Pretty cool little thing too, because it's got all these nice buttons on it. Has a little OLED display. What does not work? Other Lone Star has been through this device to try to find stuff that's wrong with it and wasn't able to repair it. So I'm kind of excited to take a look and see what I can do. I don't exactly have the composite videos to go into this thing. I wouldn't really have a use for this because I'm not doing SSD storage. I'm doing platter storage. But this thing will allow you to put 2 SSDs in there, and then it's got like a light pattern for when it's recording to one of them. It'll switch over to the other one automatically too. Apparently this belonged to, I think, was it New York Times or something like that? Leb can, or sorry, not Leb, the other Lone Star can talk about it when he's around. So can bother repair it. I don't know. It's SDI, not analog. Yeah, it's the old, it's super duper composite whatever. I don't know what to call it. Yeah, it's SDI. It's like coaxial cables that go directly to, yeah, this thing, and it records, and it's got outs from there. Infinite power through weaponized stupidity. It's true. Hate wearing a mask because my glasses get fogged up. Yeah, you need to just find one with a strong nose band. Yeah, everybody should get the fucking shot because it's like the difference between the probabilities. Just look up the probabilities, and all that information is out there. You can see the benefits. I have this extremely powerful motherboard that I really want to use. This is so much power. I saw Jacose got the same one for his dad, and I'm like, am I a dinosaur? But this is like super duper modern, and I would really like to use it. I was working with Asus, ROG Strix, or no, it wasn't Strix, but I was working with that this weekend. My friend's computer is, I don't know what the fate of that computer is. We put it together. It was a hardline water-cooled system. We didn't test it ahead of time. The first thing the guy at Micro Center asks us is like, so this all worked when you tested it, right? And we're like, what? What do you mean? You mean tested it? We didn't bench test the fucking thing before we put together the hardline water-cooled system. We did all of the, removing the graphics card from its heat sinks and putting it on a new one and unwrapping everything and putting it all together. We did not test it. Whoops. So he's having somewhat of a RAM problem. A RAM problem and possibly a Gen 3 to Gen 4 PCIe riser cable problem. So we took it to the computer store because they sold us all the crap, and then they can deal with it from there. Hey, 4N6 expert. We got 2 names to go up. We got 2 names to go up right now. Man, I'm like sweating. It's like gonna be 100 degrees out today. Fahrenheit, freedom units. We had Fibonacci 1321 sub with a prime. By the way, if you guys are interested in the music that's playing right now, which is pretty cool, this is Metronomic Live. He does streams out of New York, out of his apartment, etc. Sometimes shows back before COVID. And yeah, he plays really cool tunes. Really cool tunes. I found this guy through Tom Thinks, who was on the front page of Twitch the other night, which is crazy. That was so cool. He had a huge viewership because of it. It was great. Let's put 4N6 expert and Fibonacci 1321 up on the board. Yeah, his apartment absolutely, definitely has a nice view. Seems to have a nice view. It's all green screen. It's very elaborate green screen, but we'll pretend that he has a nice view. Yeah, it's a really crazy fucking view. He's got a view of like, I love when you can see the cars rolling around the highways and stuff around New York City. don't know why it's so hot in here. Oh, I also spilled shit on my keyboard, so possibly Thursday's project would be repairing my keyboard. If there's any permanent damage, I gave it a bath in alcohol because I had that sprayer prepped. So I sprayed the ever-loving shit out of that thing. Oh no, Fibonacci! Well, there's no better a name to partially cover up than that one. I really don't like that one. So, Fibonacci 1321, thank you for doing your civic duty to erase shitty memes off of my board. I don't know what that collision is all about. I mean, we didn't in our simulations, we didn't have any collisions, so I don't know if there's like a database size corruption issue or something. I don't know if we'll ever know. 4N6 expert, welcome to the board. I did conformal coding before on that keyboard, that type of keyboard. It eventually died, but it was pretty resilient while I conformal coded it. I don't know if the problem is the back of the keyboard or the front of the keyboard. I'm not sure which side is the problem this time, because that wasn't the best thing in the world for me to spill. But yeah, it did a number on it. I'm turning up the fan. I'm gonna need it today. Even though we are just kind of sitting at the computer today. I'll get stuff out in just a second. I just got a new screwdriver kit. I think it was probably about time. New screwdriver kit. can't they agree to a bit standard like USB? I mean, there are standards. It's just hexagonal, you know, drivers. There's just 2 sizes in that kit because it's made for a couple different purposes. One of the purposes being like home stuff. So like driving a screw into the wall, you'll want to have a little bit more torque on the screwdriver, and the other one's for electronics because it's for small stuff. All right, let's get some RC car stuff out. I gotta close Fusion on my other computer. I'm sweating already. I don't know how long we're gonna be able to stream today because I might be too warm. I was considering whether or not I shouldn't have promised today's stream, but I'm gonna be doing this anyway, so I might as well do it on camera. Might as well do it on camera and have you guys with me for this tedious and frustrating process of getting parts into Fusion properly. At least They just don't have a schedule. I don't understand. Of course, I have to be opinionated and have a strong personality in order to do this, so you should know that I don't really care, but I'll talk about it anyway. I kind of do. I hate setting my obligations. But I got obligations, you know? Gotta bring a nice stream to you guys. Oh, so check out the results of last week's Fusion 360. It almost fits, but not quite. I still gotta figure this one out. I'm gonna get this to fit inside of that computer shell in order to get air through our radiator, but we designed a fan adapter. Well, there it is. It's pretty good. Pretty good the first try. First try. Yeah, look, it looks like a... Oh, looks like a sci-fi set. Yeah. Here, I'll show this without the music going, without the start soon going. We'll get rid of start soon. Get rid of Metronomic Live. Banished. Now, Metronomic Live is awesome. I hope he does another set soon. Especially given that everybody's fucking locking down again because of dipshits. I'm livid. I am fucking livid about dipshits causing us to go into another wave of COVID. We should have been done with this shit. I'm angry. Anyway, no, those are designed with little notches in the fan blades. Those little notches in the fan blades are apparently the secret formula to making a quiet fan, or they're just decorative. I don't know what the decision was on I don't know what that decision was on Noctua's part, but they apparently have done the research, or they just put it there and it doesn't do anything to quiet down the fan blades, and it makes us think that they're more technological than they actually are. I think Noctua's main formula is have a really good bearing and then have good plastic on the rest of this thing. The fans that I worked with this weekend, my friend was building a 30... Oh, I'm gonna start coughing. That's great. I love coughing. He was building a 3090 hardline water-cooled Lian Li case, 5650, I think, AMD, Asus boarded, super duper ultra computer. And my friend and I went over to his place and helped him, and they were day drinking the whole time, which is annoying. I just don't do that. I don't mind it. It's just I don't do that. And we put the whole thing together. He bent the tubes himself, which I was like, you guys have seen me bending water cooling tubes, right? You guys have seen me bending water cooling tubes. It sucks. He got it on the first try. I don't know how. I don't know how he got that all on the first try. He got it on the first try. They were cutting tubes manually and just free-form bending them. He had the bending forms. He didn't use them. He just free-form bent them, and they were perfect. I mean, keep in mind, this is a Lian Li case that has an EK... I don't know if it's EK or not, but it has a distribution block on the front, which was also a reservoir. So that distribution block means that all the tubes were in just about the right place to just come out, turn, go into the thing. Pretty crazy. Sounds like you found yourself a tube bender. I think his brain would break if he saw the types of bends that I tried for this. I'm going to use soft tubing for the water-cooled PC, for the stream PC, because I want results and I don't want to sit there faffing about. Well, I've been through so much tube trying to get it right. Yeah. Got a technical interview later, so we talk about socket and concurrent program. I don't know anything about that. Yeah. So yeah, we put together the entire thing and then it wouldn't post. We got a dreaded D0 or 0D error. We got his old RAM, plugged in his old RAM. By the way, the water cooling system, perfect right out the bat. Absolutely no... Yeah, I know, maybe the drinking helped the tube bend. Maybe he reached the... What is that point called? Named after the Microsoft programmer where you're just drunk enough to put all your ideas down into code. I forget what that name... The Balmer. Yeah, Balmer Peak. There you go. Yeah, maybe they reached Balmer Peak doing that. That might be what it is. We got the whole system plugged in. We got all the water pipes like pretty well vetted out for bubbles. No leaks at all. He got it right the first time. I'm fucking impressed. I'm like super happy for my friend because he did this perfectly. You know, like removing a 3080 from its heatsink and then putting it onto a water block. That was a little stressful. You got to really put some force into the board to get it to let go of all that wonderful heat compound. Ugh. Got it all together. We had to go back to Micro Center, which is 50 minutes each direction. Yeah, only just $2,000 of potential damage sitting right in front of you in this fragile fucking thing. All of those, the tiniest capacitors known to man, are on that thing. And then the friend of mine takes the EVGA cooler and he just throws it in the corner. He literally just yeeted it into the corner, and I was like, ha ba 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 ba. It was, I guess there's no real use for the cooler afterwards, but I would keep it around in case I, wanted to, like, in the year 2040, relegate that video card to some other task that's not gonna be conducive with water cooling. I would want to keep that cooler around, but he just yeeted it. He didn't give a shit. We got it all together. We got the RAM in 0D, took the RAM out, put in one singular stick of known good RAM. Didn't work in one slot, didn't work in the other. Got us to another error in a different slot. We still weren't getting a BIOS. We still weren't getting video. It turns out the 90-degree riser that was sold to us, basically it had a Gen 3 cable. So you've got a Gen 4 PCIe device with a Gen 3 cable going into the motherboard, which is Gen 4. And the thought is maybe we need to plug it in directly and then get the BIOS to read it as Gen 3, and then maybe more of the stuff will work. Those risers are a lot of culprits, yeah. But one of the things was, like, we ran out of resources. Like, we didn't have known good hardware that we could swap into that computer just because of compatibility. And my friend hasn't built a computer in like 6 years, right? Riser cards are not standardized, so I've read it could be anything. Yeah, they had Gen 4. It wasn't a riser card. It was a cable and like a bracket that puts your GPU at 90 degrees, which is a good idea because then you can see more of your cool water cooling stuff. But I mean, we plugged everything in. We got it to light up like a strip club. It looked like an absolute 1970s nightmare room with water. But we ran out of resources, so we took it to the computer place. This isn't just a computer place. I mean, this is Micro Center, right? And so we took it there, and they're currently diagnosing it. We don't have any word. They're still working on it. They have the stuff, they have known good RAM that they could put in. They have known good parts that they can swap in. And they have people who will probably be able to get like a soft line water cooling setup if they need to plug it in directly, all that stuff. So yeah, that was my weekend. Unfortunately, we didn't finish any water cool builds. Hey, got pretty close though. It was still fun. But yeah, I think our biggest mistake, and one of the takeaways that I want you guys to know, is that, if you spend multiple thousands of dollars on a new build and you've got all the stuff sitting out in front of you, bench test it first. Bench test it first. We were too excited to build the stuff, and we jumped into the water cooling, which didn't harm us completely, but it still made it a little difficult when there were growing pains. So yeah, bench testing is your friend. That's the lesson. That's the lesson. We went to the computer store, and he's like, so all this stuff worked when you bench tested it, right? And we're like, that would have been a good idea. I already showed the rack mount thing, Lone Star. I've got it sitting kind of buried in the rack back there. I think I'm gonna get to that Friday, but yeah, that thing shipped really quick. The badass video recorder over there. I don't use any SSDs to store stuff though. For me, it's a platter drive, and that's like longer term storage until I can bother to put it on YouTube. But yeah, that thing's a pretty badass little video recorder there that we will take a look at. See if I can fix it in any way, shape, or form. This was the other part of from what we worked on last stream. I made some 140 to 120 millimeter fan adapters, and they printed pretty well, aside from my printer having some kind of an infernal, unrepeatable x-axis shift. I don't know where that comes from, but it eventually works it out. The device is made for more for speed. Okay. Oh, so it's like it insta-writes everything. Yeah, because I would assume that. I guess that would be better in industry if you can afford the storage. I I just, you know, platter drives are cheap and they store a lot of stuff. So anyway, we made a pretty good, oh, and playback too, yeah. So we made a pretty good fan adapter out of this thing that's about 10 millimeters deep. And that'll hopefully, when I bolt it into the main chassis, that'll get us that little bit of space, that corner of the maker beam front end of that rack mount case. It's just going to be this, and it's not going to look all that pretty, but I'll still be able to hook everything up to this. And then I've got another radiator that goes in the back. So I'll have 2 radiators on the thing. Gotta have those 0 delay instant replays. Yeah, man. When you're the New York Times recording an interview podcast or whatever. So anyway, that we completed. This is pretty good stuff. You know, all we needed was a little adapter. I probably could have made it out of foam core if I really felt like it, but it's good to get that done. We'll get back to that computer project in a bit. I got carbon fiber rods, I got RC car parts, and I got 3D models. That's kind of what I want to work on today, because that's what I'd be working on anyway if I did take the day off like I normally do on Wednesdays. But it's not really the sort of thing where I can take a day off to order parts. I don't need to order parts. I didn't work on anything on Tuesday, so this little RC car has been a bit of a project vortex for a little while. And I'm having a good time working on it, but I want to make some significant progress so that I can actually turn it into an RC car again. It's definitely not an RC car right now. Right now, it's just a bundle of money that I piled up in a particular shape. The things that I have done to this have involved light CAD and now heavy CAD work in order to figure out where things go, how I'm placing stuff, how I'm building stuff. Basically, I bought the carbon fiber parts for this chassis. I whipped them onto the thing, raced it around, broke the plastic parts, replaced them with metal. That changed all the suspension dynamics. Had to order a bunch of different suspensions in order to find one that actually worked and wasn't just made out of cheese, and then turn that into a single shock setup, which is a little bit more light and spry. I don't have a lot of clearance on the ride there because these are not shaved to 1 millimeter, whereas the ones on the original chassis have been shaved to be 1 millimeter deep, which I find kind of interesting. I'll have to look at that later. In the meantime, what I've been doing is trying to convert the kit over to the 130 size motor, because the 130 sized motor has more options. There are more powerful and interesting motors that can be put in instead of the 180 sized motor, which is this thing here. Hold on, I'm getting it from the other desk. This thing here. The 180 size motor takes 2S batteries, whereas these will explode if you put 2 cell of lithium ion through them. Case and point, the power dash motor that I had originally fucking exploded because it had too many volts going through it. So in the process of doing the motor conversion, I figure I need an H-bridge that works off of 1 cell, supports the amount of current that these motors draw, and allows me to organize a lot of the wiring on the thing. So I came up with this circuit board here, and I used these big plugs for everything, and everybody was happy and nothing went wrong. Actually, fucking everything went wrong. I miswired. I put the wrong part in for the Arduino, which is an ATtiny85. Put the wrong part in Fusion. I got too small of a chip on that. And then I put the wrong setup for these new MOSFETs that I found on the internet. I went on DigiKey and I'm like, hey man, what's good? And I looked at what was new, and I found these power MOSFETs that are actually pretty goddamn brilliant. We set these up on the bench after the fact, and man, they are cool. They work really, really well. They dump all their heat into large traces, which I'm going to have to replicate. But they run really well with these motors. They allow all that current to pass, and they get a little bit warm, like we can see them light up on thermals, but they don't overheat. And they don't have a lot of excess heat either. Whatever they're doing in these things, whatever this trench technology bullshit is, it's doing pretty well. And so I'm excited to use those in the final thing. Except, well, we still have like a voltage spike problem. So I may need to add quite a bit of filtration so that the motor doesn't take out the rest of the electronics. The powerful motor doesn't take out the rest of the electronics. We'll have to set that up on the bench soon. In the meantime, I kind of want to get rolling designing a circuit board for this, because what I'm going to do, look out, what I'm going to do is put the entirety of the electronics right here in this spot. So in order to do that, I needed to figure out a different mount for the motor. Right now, this motor mount had me poking holes into the 130 sized motor can and then drilling in, not drilling in threads. I mean, I basically just forced that screw through in order to create threads. And I don't like that. I really don't like that. If you want to change the gearing and change the mesh, you have to loosen and tighten these screws. And if they strip, you're dead. And it's screws that aren't meant to go into this can, going into this can. If I want to swap motors, I need to drill holes in the motor itself, which means I need to take apart the tabs on the back of the motor and disassemble the whole thing and reassemble it. I don't want to do that. So what I did was I came up with a 130 sized motor mount for it. In order to do that, I needed to model a lot of the different features of this pan and the transmissions that go on it and all that stuff. So modeling the transmission was absolutely, I'm calling it the transmission, it's the differential housing, absolute pain in the ass. A lot of the other stuff I could reverse engineer parts from. And then finally, when I got everything together, one of the dimensions wasn't coming through properly. Why wasn't one of the dimensions coming through properly? It was like if I measure from the edge of the plate to one feature, I got one number. Then if I measure that feature to the other, I got a different number. And it was very hard to like narrow down exactly what feature was causing the weirdness in the measurement. Part of it was spacing to the holes, but the other big violation of all of my measurements, right there. You see how this hole's kind of centered on this, and it kind of makes that feature. Well, this one over here is not centered on it, and it kind of violates that feature. You can see I used it here. I didn't use it here, because this doesn't fit. This technically doesn't fit. If I place this in here, this hole, which is kind of like a center point of the entire design, that hole right there is designed to grab onto the top of the motor mount and keep it a certain distance from a ball bearing inside of there. The ball bearing, where did that part go? Yeah, here we go. So this is the stock motor plate, and it's got this hole for a ball bearing, and then it's got that location point right there, right? So what happens is, my theory on what the hell's going on here is that they sourced a bearing that was supposed to be 2 millimeters, but it was 2.5 millimeters. And so this didn't actually fit with that spur gear placed there. Now, if I move this out to the further position, it does have that enough room to kind of like sneak in there and probably fit with this. But I was on the narrower body, whatever. But yeah, that doesn't actually fit. None of that stuff actually fits properly. And that might be part of the motivation for why they moved the holes on this in order to space it out just a little bit more. But it's incorrect. It's a fundamental problem with the model itself. It's absolutely ridiculous. So I have had to redesign this part, but make it correct. I came up with this, and it's got a little cup there for the bearing. The bearing has 2.5 millimeters now. And then I've also incorporated a mount for the 130 size motor, which basically just needs just like a little collar around this, and then you can make something that clips onto here, and since that is a flat edge, that'll keep this thing from rotating. That's essentially what we've come up with here. Is I've got a disc around that piece, I've got a screw that locks it down, and then I've got a screw that locks this one down. I didn't do the side screw, even though it's there. I figure I don't want pressure on the side. This will just lock it into place. And so it meshes really nicely, and there's not a lot of resistance on that. That feels nice and free. God, but this is like the culmination of like tons and tons of work to try to get all the measurements correct, just to make sure that I'm not screwing this thing up. But now that I have this model, I can determine what size a circuit board is going to fit in here. And here's an earlier revision of the circuit board with parts that are literally just thrown on. This, because I have the schematic of the other controller board, the other motor controller board, I moved the parts into this one and then made an additional assembly that has these daughter boards on them and just kind of placed stuff around to see what sticks. So this is where I am with it. This is not the current board. I've made it a little bit smaller. I figure there's going to be 2 holes in this thing, and those are going to come from this base plate here. So instead of the servo holding piece coming up and meeting this at a post, I'm probably going to have to lengthen these posts. I didn't want to do that because those posts are more difficult to print, but I think it'll be fine if I just take them all the way up to this, and then those go straight down so that this can print on the bed facing the direction that it is right now, and then I'll have additional screw posts coming off of this weird Y piece that will allow me to put 2 tiny little screws in this and hold it in place. See, those screw locations are important because their space is at an all-time premium on this board. This has to be like, I mean, since I'm using 0805 parts, because I don't want to order a bunch of 0603s or 0402s, I don't want to have to order new parts. So I'm going to use my gigantic, you know, LEDs and stuff on this. That's going to put a little bit of stress on the design, but I think I'll be able to achieve it. I just need to make sure that I avoid screw posts and screw heads and all that stuff. So in Fusion 360, in order to do that, I mean, I basically just start an electronics design. I had the schematic already with all the parts chosen. That's the important part, is having a library of 3-dimensional parts that you can use in order to make boards like this, because Fusion will do all of this pretty stuff where you can be, oh, look at my board, it looks so cool. It'll do all that stuff. It's just that you need to provide it with the library parts, and working with a library has been an absolute nightmare. It always is. I need to spend, what, like a week or 2 just making my own custom library that I can import into my designs of known good parts that have good 3D models and all that stuff. I think that would be kind of a useful thing for me to do, because then I could roll out these designs a lot faster. I can make it look easy. Right now, we got to import some stuff into this actual electronics design. So let's open it up. Let's open it up, and you guys can see how the different pieces of Fusion will work with one another in order to make a pretty board that we can figure out where it is and do some 3D modeling around. And I'm not going to order the board because we don't know what kind of additional filtration we need for the motors, because we had trouble with that. We made a breadboard setup. So we'll come back to the breadboard setup at some point when I have a good idea of how to filter out transient power spikes in a motor system, in an H-bridge motor system. I might have to do Zener diodes or something set up in a particular way in order to block that negative voltage from killing everything. I don't want to have to use a giant capacitor because I don't have room for a giant capacitor. I don't know where I'd put it. There's no space for a giant capacitor. I could probably chuck it like right here in this spot, but that's pushing it a little bit. I could put it right there. There's a little chasm right here. Here, if I unview the circuit board, this is the only spot I have for a capacitor. But yeah, this is the first time that I've taken something so comprehensively into CAD and had like a big model for everything. I'm pretty happy about this. If you guys are interested in this model, I can share it when I'm a little bit more done with it. I'm happy to share this stuff. It's more about the processes and techniques than anything else. I think wltoys might be a little perturbed with me reverse engineering a lot of their stuff, but like these metal parts are technically Chinese parts, and they actually give it a slightly wider wheelbase that we have to compensate for. So part of doing the whole pan and modeling it out like this means that I can now drop bodies on this thing too. So once I make this design and make it nice and clean, aka not importing my electronics here at the end, I'll have to go back before this step, import the electronics, and then repeat the things so that I don't have basically so that if you go back and you edit a component, it doesn't revert the drawing to too early of a previous state, right? I want all the stuff in there early, and then all the stuff that's designed around the positioning of stuff to come later on. There's a process that I want a sidecar capacitor. I could put a giant capacitor over here. I mean, there's a little bit of space right here. I was thinking about tying this together, tying the motor mount to the servo plate, but then I would have to print this from a different dimension, or I could perhaps I could put a piece on this and then come up into here where it screws into place. Like just have like a little brace that goes sort of near the motor, but I don't know. I don't think that's really necessary. I don't think that's strictly necessary. The motor's in there. It's under a little bit of pressure. At some point I might want to like distance this a little bit more. That would mean going back into the steps and altering the extrusions. And that would give the motor a little bit of room to breathe. Because right now, when I try to put the top bar on, this piece here like leans forward a little bit. Only a little bit though. I mean, it's the whole lesson behind gapping devices. You know, if you want something to grab onto the screw, 0.2 smaller than the threads is a great number to use. If you want something to slip through, 0.2 greater than the screw. And when I clicked on that screw, Mass Effect sounds came into my head. Because when I was designing this part, I was watching another streamer play Mass Effect. It's weird how that works, that auditory association you get. Oh, and by the way, this looks so janky up here. That's because that's gapped for the servo saver. I didn't bother to model the servo saver. I just put this in the position where the servo saver sits, so that I could position this expensive all metal glider servo into that spot. I've got one of these with wings and the other one doesn't have wings. Like $44 for the servo. Ridiculous. Vertical servo placement. I mean, I guess. I did have a different type of servo that I could have tried. I didn't bother to get it, though. This is the larger version of that servo. I thought maybe I'd need the larger servo for the torque. But it turns out the little tiny servo is just fine. Yeah, this thing would fit in almost exactly in place of that, and it would be in all the same positions and stuff like that, and it would not interfere with any of the other equipment on this. And I could have designed a little 3D print thing in order to, you know, properly mount it and all that stuff. But I ended up going with the smaller version of this servo, so without the motor sticking out the end. But this is what's awesome about having the CAD models, that I can go in here and I can alter this stuff as long as I'm careful about the timeline. You mess up that timeline, weird shit starts happening. Just like the real timeline. Can't mess up the real timeline too much. But yeah, that's okay. I'm not incorporating that part. Control Z that one out of existence. All right, so for the circuit board, I've got a certain amount of space and I want to be cognizant of the things that are sitting around it. I mean, I went through the trouble of reverse engineering the battery tray holders just so that I knew how far to the right I could actually go before I really start to run into stuff. And if you look on the real thing, it's just about correct, although that comes out into this area a little bit more. So I gotta be careful about that. I want to get this right the first time. I figure what I'm probably gonna do with the power switch is wire in a plug for the battery to plug into the power switch, and then the power switch will be directly wired into the actual circuit board. I don't have a lot of room for connectors. And so that's where I'm going to, well, that's where we're going to be starting today, is with connectors. This is an old version of the design, by the way. This is just to see whether or not this servo could handle, you know, steering the car, which it can. It does a really good job. So, all right. Yeah, these are the latest versions of the prints. And it works pretty well. You can see here that it's pushing this thing forward. And I'll have to deal with that. And then, unfortunately, this post, I think that post needs to be moved back just a little bit. The problem is, if I move that post back, that was the first datum point for the entire design of the servo tray. So if I move that point, I have to go through the timeline, fix all the little chamfers that I put on the thing in order to make it look good. So I don't really want to do that right now. I don't really want to fix all that stuff. It's kind of fiddly. I think I'm going to leave it the way it is. It's off by a tiny bit, but that's taken up by the screws. This one probably does need to be fixed, though. That's for a later date, though, because right now everything fits. It's just under a little bit of pressure. Oh, yeah, and then the other thing that I was going to do, the other thing that I'm going to do, and I haven't figured out what glue I want to use yet, is these posts. I bought very cheap carbon fiber rods, and what I'm going to do is glue them in. I'm going to glue them into the 2mm posts, and then I'm gonna re-drill this piece, because this is not acceptable. These are off by like a 0.5 millimeter or so, which means they're like impossible to fit onto that. I don't know how I did it with this. Either I forced it on or I got real lucky the first time, but like this doesn't fit. So I wanna make sure that it, and I'm not gonna like alter things in a weird way to make it fit. So I'm gonna have to repair this so I can get it right. Whew, that's a lot of stuff to catch up with you guys on. How's everybody doing today? I regret I didn't take my phone with me to dog walk. Saw a woman smashing a Tesla with a wire wrench, with a tire wrench. Well, thanks for sharing. Are you interested in digital animation? Like from a hobby standpoint, I think it's cool. I like learning about it, but I haven't really taken any steps to learn it. I almost went into digital media. If engineering didn't work out with me, I would have gone into digital media, which involves, you know, that kind of stuff, like digital 3D animation and stuff. Just found out they don't make 0805 electrolytic caps. No, yeah, they don't. Caps are a particular size set. Have to relay out a PCB. Can you, within the voltage parameters that you have, get a smaller cap or something that barely fits on those pads? You could still potentially salvage the PCB. Unless the size requirements are such that, you know, all that stuff's going to throw you into disarray. All right, so here's our job. We have to lay out a PCB that fits in this extraordinarily restricted space right here. Why would you do that, oh bother? You have the entire top of the car, which is typically where the controller goes for this thing, right? Oh, source material, close. That was all for, okay. That was all for just modeling of fans. Don't need that. Oops, I closed the browser. Oops, I crapped my pants. All right, so this is wltoys 989. WL989. Just show you guys what it looks like. Why, I mean, you know, why am I married to this size? You guys have heard it 1,000 times now, is that mainly my initial inspiration with this thing was that this is the size of RC car that they used for the Mario Kart home circuit. And so in our super advanced, our ultra advanced methods of cheating were to add stuff like a differential and things to the Mario Kart. Well, it turns out it's already in this size. So if we just cater to this size, we can add those things that make cars just a little bit faster, so that we're not totally cheating, but we are giving it better racing dynamics over different surfaces. And the thought was I could make a big Chungus one and then a super Leggera version. So one that's really light and nimble and has full suspension, possibly not all-wheel drive, and another one that is off-road, all-wheel drive, and heavy. Now, it's been too long. It's been too long. So that's not really tenable in terms of projects. I can still play around with it and do it, but striking while the anvil is hot was probably a better idea. And if I had really concentrated on this and you know, knew about this scale of RC car, I could have really done something cool very quickly, and then gotten that to people who would make it more popular than me. But oh well. In the meantime, I've kind of fallen in love with this size of RC car, because you can get up and around furniture with it. Doesn't really go outside. I mean, I guess I could go on the blacktop and race it around, but it's sort of like if you've got a flat surface, this thing will be a decent scale for that. You can zip around and you can drift it very easily. So that's sort of my love of 1/28 RC cars in their limited availability is sort of part of the motivation for this. So the wltoys kit is not the KuroKesu, I think, Mini Z chassis. It's its own chassis. There's like Mini Q, wltoys, and Mini Z. Mini Z is like a $200 RC car, and it's pretty comprehensive out of the box. wltoys is like a $60 RC car, and you have to massage everything in order to get it to work properly. They kind of took a philosophy of, well, none of this stuff really fits together that well because we were really cheap about it. So let's put a big motor in it. And so what I'm doing is I'm taking the Mini Z philosophy of like, lower voltages and we got more limited stuff, and you kind of tune your way out of the problem. And I'm applying that to the wltoys kit because it's a decent chassis for me to like do experimentations on. And then Mini Q sucks. It just sucks out loud. I got a Mini Q chassis. We took a look at it. It's fairly functional, but it's not good. The dynamics of it are not good. It's just not good. So anyway, the wltoys kit, you can get these things, you know, they're all pre-assembled and stuff. But what they have is, and I'm trying to look at what, like, look at what this guy has. He's got all the, that's all YouTube results, huh? Budget 120. Look at this. This guy has a whole racetrack. Oh my God, that's so cool. That's cool. I want that. All right, come on, buddy. Oh, this guy's going through the ringer. This guy's really like taking it to. I got that drift differential. I'm gonna have to watch this video later. I'm trying to just get a picture of the chassis so I can show you guys. Here we go. So on that top rail, they're basically mounting everything, and for no reason at all other than my own personal satisfaction, I would like to fit all that mess, all that motor controller mess into here, just right under that, so that there's nothing getting in the way. So that's my motivation behind everything. So that's what I did with modeling this entire chassis, just to figure out what kind of restrictions I'd have in this area. Then, of course, I'm going to use this model to fit a body to the thing, too, which will be pretty cool. All right. Electronics. So that I'm putting in DOS Redux, because we're using DOS micro stuff in order to get this thing rolling, which means the radio receiver and a gyro are the two components for the DOS micro stuff. So I made a very preliminary model of these. Basically, I threw a couple components down onto a schematic in order to match the size and layout of this thing. They're not quite exact matches, but they are in the precise locations of these, and then I measured them just right to get that PCB size right. I even did the PCB color thing that I forget how to do now in order to make those look right. So those are parts that I'm going to put together in a subassembly, and that subassembly will become a component in this drawing. So what I do is basically I've got PCB small, and this is the smaller PCB for this thing, and then I have PCB, what is it? Here, small DOS assembly. So small DOS assembly is all the stuff put together in Fusion in order to create the component that I'm then going to drag into this drawing. It's just weird like that. Do you do your own PCBs yourself? No, I send them out to do them somewhere. It doesn't make much sense to have all those chemicals around these days. Getting PCBs made even locally. I'm in North America. I'm in the northeast of the North America, of the northern of the America, the continent things. Anyway, northeast, and basically I can go to a PCB assembly, not assembly, but a PCB manufacturing service and have something made and get it here pretty quick. The place that I always go to, though, is Seed Studio, only for the fact that they were one of the early batch services, and I know the type of work that they do. That's the only reason I go there. I should give some of the others a try, like JLPCB and some of those other ones, because they have a pretty decently quick turnaround, and they'll get you PCBs, you know, like 5 for $5 if they are of a reasonable size. It's like, it's a joke now. Local delivery places charge more for a bottle of Coke than they do for to get your own custom PCB manufactured. Like, why would I bother to have etchant solutions and laser printers and all that stuff around when I can just literally yeet my files over to somebody and they're going to skeet it together onto a board and then yote you your boards back. I don't know what words mean anymore. I'm starting to sub in Gen Z words and they're just gone. JLPCB got me stuff in under a week last time. That's pretty impressive. Yeah, I'll have to look at that. If you really want, you can get the After Dark service, which looks really cool. What about using a CNC to mill a PCB? I've done that once. And it was for a project for a 3-letter agency. And they did it themselves. Because they had to do it locally, because it's not like we're going to send something like for a court case out to some rando PCB manufacturer. But they did the milling, they did the solder mask spraying, they did the silk screen, all to exactly my specifications. they had to take vias and individually place them inside the vias. They had like an expanding riveting thing to do it. And the PCB that they provided me with was a little bit crappy. It was a little bit crappy. It wasn't really that great. These processes that produce PCBs are meant to be done in like bulk, in like a big bulk operation. So panelizing everybody's PCBs and then running them through that process, it's great, because then you get all those factory process results, all the automated factory process results in your short run PCB. It's a different world out there, man. You don't have to stress about like CNCs or any of that stuff. You just send it out to a batch process. I don't know if that'll like eventually not be a thing, but I'm so happy that it is. Right, so sorry to crunch ice on camera. You probably shouldn't. I've got like fast food ice in soda right now. So what I want to work on is the electronics design. So DOS board schematic was the one that I transferred from one design to the other. Some of the other, like DOS board is the larger design version. This one over here I called smaller board because I couldn't be asked to do proper naming techniques with this thing. So I'm going to open this up, and this is going to open up all the files for it. So Fusion 360 is just going to take a shit. Everything is out of, yes, everything doesn't work with everything else right now. Of course, Fusion has to open up 6,000 things, and then it comes back over to here. So what this design, what's incorporated in this design is a schematic, a board layout, and then a 3D design. There's a little bit of crosstalk between all these. They're supposed to all be synced up, which means that Fusion is just going to constantly warn you that things are out of sync as you work on these. The schematic tells you what all the parts are and what all the parts connections are exactly, right? Tells you what parts are there, what parts are connected. The PCB layout gives you the outer dimensions of the PCB, the location of all of the parts, and the traces interconnecting them. The 3D design gives you that extra dimension of that layout and allows you to put holes in the design. This is the weird part here, is that the 3D PCB is what you should be using in order to interface your electronics design with basically the rest of Fusion. Unfortunately, it doesn't travel backwards as well as I think it probably should. The holes in the PCB do propagate backwards to your design here. It just feels like I should be able to do more with this. And I think it's Fusion still figuring this stuff out. I think they're still figuring this stuff out. Hopefully somewhere on somebody's working drive, there's a version of Fusion that does this a lot better, because I have some problems with this at the moment. In order to do all of this, basically I'm starting from the three-dimensional design and putting holes in it, figuring out if those are in the right spot, propagating those back to the PCB design, and then moving the parts around that. So schematic is here, of course. I had a jalapeno burp. Give me one sec. All right. Just making sure I don't like cough. My body decided that I would love to taste jalapeno again. That was always fun. Delicious. So this is like, look at how much space we have to work on stuff. It's ridiculous. My Fusion, because I've got the two video windows here, I try to squish Fusion down. Fusion really wants to exist on like an ultra wide monitor. These two sidebar things are not all that useful, so I can collapse these. So I'm going to collapse those. That'll give me a better view of everything. Can I collapse this? Yes, I can. If you've got multiple sheets, I'm sure those are very useful windows to have, but you know, I want to actually get to the designing, because Fusion doesn't let me make it smaller than it is right now. You guys, like the edge of the window is like right here. That's good enough. It's good enough. You guys get an idea of what I'm doing. So one of the things that I did with this schematic is I deleted the connectors, and instead I found a library that just has pads. So I just put pads here. They're just pads for me to solder wire to the board. I forget what size pads I have. I think I'm using the larger of the pads because I figure it's going to need a lot of current, but I think given the size of the wire, I might do the smaller pads. Looking to make my own PCBs for guitar effects pedals, and I'm probing around to see who's doing what. Yeah. For FX pedals, you might not need to make your own PCB. I mean, this is, I don't know what your project is specifically, but prototyping, I mean, just getting a perforated prototyping board with all the stuff on it that's going to allow you to do your FX, that might be enough if you're willing to live with a little bit of jank. If you really want to do PCBs, maybe you're trying to manufacture it in order to sell them, then yeah, there's a bunch of different stuff that you can do. All right, so anyway, I need a part here to connect the servo. I've got all the rest of the stuff in here, including parts that I specifically created in order to size out the daughter boards that go onto this thing. Here we have the MOSFETs that I corrected. I corrected those when we found the problem with them. So those should be all programmed in. Basically, this schematic doesn't necessarily exist to be printed out and shared amongst engineers. Now, Fusion Eagle has done a lot to make these not look like complete shit. They looked awful in the previous versions of the software. I think they've taken out a lot of the noise, a lot of the multicolored wires and stuff like that they had in previous versions. And they've made it look pretty decent. Like this, I could print this out, and I'd be decently happy with this schematic. Anyway, the whole purpose of this schematic is to program the software to know what parts are in there and what pins of the parts are connected where. That's the important part. You put down a part, you got all these lists of things that you can put in there. The thing that I'm stressing is to make sure that there's a 3D model of that part in color, and it's not just a block. Some of these are just like a box that's sort of like, why did it have to be 555? So why did that have to be the one that I actually pulled up? But yeah, there are automated tools that help you create not only the pads, but the 3D model of it in order to match whatever your device is. And we may get into that in just a little bit here, because I need a 3-pin connector. It's a Freudian. It's not Freudian. Freud doesn't have anything to say about 555 timers. What do you possibly have to say about that? Anyway, all right, so that's all programmed in there, and then from there you jump over to the two-dimensional design, and of course Fusion has decided that I would love all of this information that's totally useless to me. So that's where the two-dimensional design comes into play, and you can see here the holes that I've added have propagated backwards to this design. So now I can somewhat work around these, but the part that really pisses me off about this is that I've got a 4mm cap on top of this thing and a 4mm post below it. I can't mark that out on this. I can probably put like I'll put a silk screen circle on this in order to give me that 4mm radius around this part that I need to keep out of. From there, you go to the 3-dimensional PCB, and that's this. And now, because I've got a bunch of stupid parts sitting all over the place, these things, I got these weird boxes, right? Has anyone built a synth using 555s? I've contemplated it. I've got these weird boxes that are sort of laying out where the pads are. I don't need a comprehensive 3-dimensional part for this device because they're just pads on a circuit board. I just need to make sure there's a little bit of area around them for me to solder some wire down. So with these pads, what I can do is go into the packages here, and I can find which these are, which that'll highlight, and then I can just not view any of that. So now they are just pads, and they just look like pads on the board. I don't know why these don't shine through as much as the other ones. Like on some of the parts, I get the nice shiny thing, and then on a certain category of parts, I get not very shiny pads. But the pads are there because I've had these parts manufactured before. But yeah, I'm gonna have solder to board, so the motor and the power supply is just gonna solder to the board because I can't find a connector that takes that amount of current and is small. Is small enough. I have a feeling even the JST connectors are probably at their limit, but they're too big for me to design around. I may make these smaller. These are pretty big. Actually, everything in CAD is deceptively... You think everything is enormous and then you go to actually produce the thing, and it's like everything is absolutely minuscule by comparison. Ah. Everything is absolutely minuscule by comparison. This is gonna be a trip. This design is gonna be a trip. It's gonna be kind of difficult. All right, so let's figure this out, huh? What I need right now is a 3-pin connector for the servo. And so I was going to use a high-rose connector. I happen to have 5-pin versions of this thing. It's relatively small. Can't go too small with this connector. It's relatively small, and I should be able to get that part into the library, not with relative ease. It's a high-rose. Here, let's do DigiKey. digikey.com. Medibath! Thank you for following. So DigiKey, and then this is a high-rose D13 series. So the D13 is just a particular series of connectors from this company. This only has 4 items. That's not gonna do it for me. DigiKey. 13 position. Oh, yeah. Is it DF3D? Is the Maybe it's the DF3D series. In which case I've been calling it the wrong thing. DF3, that's what I'm looking for. High-rose DF3. Just a very simple rectangular connector. We'll do headers, male pins. 3 positions. Series is 3. DF3 rather. In stock. CAD model. Apply. All right, not what I wanted. Oops, no, get out of here. Ah, close, although that's a slightly different one. That's got a different design to it. Where's the one that I selected? It was like super easy to find. No. Definitely no, maybe. No. See, okay, I got the part. I got the part in CAD. I'll just open it up from here. So this is, if I go to my admin folder where I'm keeping all these projects, I've got DF13-3. Yeah. Is that the one that I wanted? There's the JST. DF13-3. Yeah, that's the right one. So let's see, that would be DF13-3 high-rose. Oh, well, now you've got it, you little bastard. Jeez, you like trick DigiKey into showing me the right thing. So this is essentially the connector that I wanted to use. DF13-3 1.25. Maybe the thread pitch, or sorry, the pin pitch on this. We need to get this into a part. And high-rose provides you with the drawing of it. So I took the drawing and I imported it, and all the colors were wrong. It was just a terrible thing. So what I did is I used the appearance toolbar in order to make this thing look right, and then I located it at origin point so that it wouldn't be an absolute nightmare to work with. So I took their model and redid the appearance of the faces to give gold to the pins, and then the proper, whatever that plastic material is, I think nylon, the nylon appearance of the rest of the thing, right? Because I want to be vain about this. I saw that black connector earlier and I was like, ooh, that would look good, but no, we'll keep it with this. Okay, so that part I now have in CAD, but it is not associated with any kind of a design. None of the pins are right. Nothing really matches up. Like, I mean, it's the right part physically, but we need to get it into like a model. And so the way that I understood about doing this is that you can open up in the library manager, you can edit your library, and then you can add a part. And then from there, I guess you import all the stuff for it. but I don't have any other stuff other than this model. So I guess I guess I'm tasked with creating some of the stuff. I've had trouble with this workflow in particular in the past. This is like a completely unintuitive workflow. And it's like certain things you can't do in the order that you would think that they have to be done. Like, why are there 2 files here? I don't know. I don't know why there are 2 files. Why are there 2 files down here? You know, this process has been somewhat aggravating over the past. They need to come in and kind of like, there's no excuse as to why I can't have like some field where I can work on all this stuff and like drag and drop stuff around. But all right. Anyway, complaints aside, what I'm going to do is open up the library manager. So we're going to go all the way back to the schematic, which is where we worry about things like parts and libraries and, you know, components and stuff like that, right? We need to have a 3-pin connector right here. So what I'll do is I'll add a component, but then, oh, look, it turns out we don't have that. I might have started on this. Yeah, we've got some high-res parts, but they're not the right thing. None of them are. They're just whatever. Jesus Christmas, that's a big part. Yeah, and that's an antenna. So none of this stuff is going to work. None of this stuff is going to work. All right. So what I do next, this would be a connector, and it is a specific type of connector. It's not a generic header. So I actually want to open the library manager, which is the button on the lower right. And all these libraries are managed, which means that for some reason, Fusion has decided to take all of my data and not allow me to share it. So managed components, this would be managed connectors. Why is it not in there? Available. This is what I mean about having to go back through and clean everything up in this. I really need to clean up a lot of this stuff. So where's my Jesse something. This is unfortunately a part, like if you want to be able to be quick with designing products and stuff and then have that full-fledged 3D model of the thing, you can get very quick at it, but it's going to take a lot of background work to get all of your components and stuff properly vetted out and have all the right pads, have all the right packages, have all the right 3D models, and you can go boop, 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 right? You can put together this stuff real damn quick. Yeah, I should have called it 1995. The joke is that it's like 2 years behind. Where's Jay? Scroll. It's going to get out of Worth and just suddenly, yeah. Spark Fun. There are places that you can get libraries from, and you can get components that are like fairly common from places that are like trying to basically get you to use their library. The manufacturer is always going to have the best 3D model of their component, and then it's up to you to figure out what the pads look like from there, because they don't give you a CAD specific, they'll give you like a step file and that's it. You know, you don't have pads on a step file. Connectors specific managed use. I don't know why I'm using it. Where is it? Oh God, why do I have 2? Well, library IO is I think where I want. That's weird that there's 2. Oh God, version 7. I don't know. Let's edit this one. Some these days will give you the schematic and footprint. It'd be nice. Yeah. Yeah, those are always nice to have. Can't rely on them yet. All right, so I need to add a component to this. I need to add a device to this. Creating a package for that device also lets me link up what it's going to look, the pads are going to look like, and the package is going to look like. This is where I had trouble with this software, like a lot of trouble with this software, because I have a 3D model that I would like to import. I can figure out pads. I could draw them if I need to. But I think the most elegant way to do this is to use some of the 3D, like the website tools that they give you in order to put these things together. So what I can do, that high-res isn't here. I wonder I wonder if it's in that other library. The managed library just means that you can use library.io in order to create the pin layout and stuff like that, which is fairly elegant. It works pretty well. So I am going to create a new 3D package. I'm just going to jump the gun right now and just go straight to this, because this will also create the footprint. Oh wait, that's not the way that you're supposed to do it. Yeah, because that opens up the internal 3D package generator, and we want to use the library.io one. How do we get the library.io one again? I need to figure this out. So if I create a new device, device name, Hyros, why are we all in caps? I guess it has to be. DF3 3-pin. Damn it, I can't get the letters on the keyboard. Now you can also import a device here too, but I don't have a device to import, so I'll just do DF3 3-pin, and this is where we'd have like the schematic symbol and the 3D model and then the board layout, right? So if I do new, add from web, this will open up library.io, I think. Oh yeah, because you can go my packages, and I got a bunch of stuff here. I mean, I could look up Hyros. I don't think this is really going to come up with anything that I need. It's all boxes. No, cancel. Damn it. Add from web. Library.io was supposed to be this big thing that allowed you to search a bunch of parts from basically everybody using the software. But Fusion did some stuff in order to like limit the usefulness of this. You can't share your personal parts with the community, I guess. I don't know who can, but it would be kind of nice if they would make this a little bit more useful. There's not a whole lot of stuff that has good 3D models. So if I look around at Hyros, I get 2 headers that look okay, not great. And that's about it. So I'm going to create a new package, and the reason that I'm doing this is because in order to get the pads that I want, I think this is going to be easier if I just create something new with 3 pins that have the right spacing. I can then take whatever 3D model that this generates, delete it, and then put in the right Hyros connector. Damn it, I need to log in. Okay, hold on. The repeater here, the MyCell that I use to get cell phone reception, it didn't have signal the other day, and I had to get 2-factor authentication. That was fun. That wasn't for this. These guys use the Google app. I can never find. Okay, there it is. Maxim provides them? Yeah. Maxim is like a boutique chip manufacturer. They usually go a little bit beyond the Call of Duty. That one's going to expire, like right now. Oh, there we go. All right, got the new device woes here. All right, so now we're in my account and everything. So now I can figure out what kind of device that I'm trying to build. I mean, technically a right angle pin header would probably be the right size for this thing. I mean, just a regular old pin header would work too. I will be deleting the 3-dimensional one anyway, since I only am really concerned with through holes on this thing. Let's just do a pin header. And now we need to figure out where all the stuff goes. So I need to pull up a data sheet of my device, in spite of already having the 3D model in CAD. I need to go PDF shopping now, which is easy enough when you've got the part up in DigiKey. So, well, I guess I could go from the spec and the drawing, huh? Oh, god damn it. Why did you download? 150 volts AC, 1 amp. Well, it's a servo. None of this stuff is good to me. This is not the mechanical stuff. So there's the drawing, but that's probably going to be just of the part, right? Yeah, not the pad layout. Maybe that's this. So this is as simple as it could be. 1.25, which I think that's 0.1 pitch, which would make this too large. We might have to look up a different Hyros to get a smaller connector. Well, that's 1.25 millimeter, right? 0.1 inch. .54. Oh, never mind. Yeah, 1.25 would be perfect. 1.25 will be nice and small. So yeah, I'm gonna take those. Get out of my way. This is technically like when I'm done in library IO, I can then find it in here and create whatever I need. Why are you minimizing? All right, all right, all right. Yeah, we're like in Windows inside of Windows inside of Windows right now. This is where things get real weird. Okay. Plus or minus 0.1. All right, so pad shape. Round, don't care about that. Footprint origin, pin 1, rows 1, columns 3. 1 by 3. 2.54 millimeters. That would be end to end. What does this thing give me for end to end on that? End to end on the 3 position, that would be, so I'm looking up dimensions on this thing. So this would be the, is that the C dimension? They're calling it the D dimension. Lowercase d. Okay, lowercase d is 1.25. Even though they don't call it lowercase d. Man, you guys are giving me weird numbers. 1.25 plus minus 0.2. We'll just give it 1.25. When I was doing this yesterday, my keyboard was dying. It was slowly no longer typing things. Lowercase b. Ultra Librarian is good. This is library IO is baked into Fusion 360. That's why I use it. Yeah, I don't use Ultra Librarian. Lowercase b is the pitch of the pin itself. That would be 0.35 plus or minus 0.5. So we can just give this one instead of 0.64, it's 0.35. Although I don't know how relevant this is going to be. L1 is the height of the pin, 2.3. Sure, let me just pull out this other software and just start using it. L2, pin height. That's not really relevant to what we're doing. That doesn't matter. I'll just leave it where it is. I'll just leave it where it is. That doesn't matter. That's not going to do anything for our pads. See, basically what I'm doing is I'm just using this in order to create the pads, and then I'm going to go in and edit it, and I'll change a lot of the stuff around. We could make it cater to this a little bit better. There were no housing connectors on the list, right? Do I want to go back? I'm going to have to redo all those numbers if I go back. Yeah, I can't center mouse click it. We'll just go with the pin header and figure out what it gives us. Otherwise, yeah, I don't think there's like a generic. I'll have to make a box around it in order to give it dimension. L2 is the height of the pins. It doesn't matter. We'll leave it at 5. It's gonna be weird. D, capital D, the absolute radius of the thing. C plus or minus 0.2. So we are in the 3 position. C 5.40. 5.4. So that would be 5.2 to 5.6. Believe me, this is easier than modeling it yourself. E, capital E, absolute width. We don't really have that here. We don't really have that here because we don't even have pin spacing on this. So I guess I could just leave it where it is. I don't know. Yeah, that's the weird part. E is capital E. We don't have lowercase e. Capital E is the width of that. 508, that's fine. L is the height of the thing itself. That doesn't matter. That's just going to change the part that I'm going to delete. So, all right, let's try it. Update preview. So that'll give us a rendering of the pin header that we just created. The absolute abomination of the pin header that we just created. The thing that's... Oh, God, it looks terrible. Oh, my God, what happened to you? Now it looks like shit. It's got moderately driven outlines on this thing, and the important part is that it has the 3 holes in here. Except that this is cursed. All right, what the hell, man? What the shit is this? What are you doing to me, man? Pad to hole ratio. Make it like 0.5. Try that. I mean, I have to have 6 mil spacing in between these. That didn't do anything, did it? Okay. All right. All right. All right. All right. All right. All right. 0.1? What's that going to do? Nothing. Let's like go to 2 and see what happens. Yeah, that does make it bigger. 0.01. Really? Orders of magnitude up. Oh my God. It didn't do shit. Why is this doing this? Maybe we need to choose a different device. Yeah, it's like it doesn't get any smaller. Son of a bitch. All right, all right, all right. These are like connected. All right, let's find a different device then. What do we got that has holes next to one another? It's not like they have a shrouded connector, and it's the right angle, but yeah, I don't think there really are any other options. I didn't expect that to fail that badly. Mauser is the step file for the connector. Well, if we could do that, wait, but just for the thing. I mean, the step file I already got. It's provided by Hyros. Yeah, that just isn't working out. I guess we can go old school with this. I'm not looking for anything. I'm trying to show this process. Stop it. Stop. All right, so that failed. I didn't expect that kind of a failure. How do I get back to where I was before? I don't think back does it. Back is just going to start over. If I go to pin header again, number of rows, 1, columns 3. I put my numbers back in here. That's going to fail again. It's the pad to hole ratio that I think is messing up, but I don't think I can get lower than what I already had, which is really weird. I mean, like pad to hole ratio, fine, but I need to have a little bit more space in here because these are all connected to one another. So it's not actually going to work in the design. I haven't run into that before. I don't think I ran into that when I made the part last time, or a similar part to that last time. It just didn't, I don't know, maybe the pitch of these was too little and it wanted too much pad around it, and I don't have any other control for the pad size other than this guy right here, the pad to hole ratio. And I guess the hole was driven by the B dimension, and the B dimension was a little bit smaller than this. B dimension is 0.35. All right, so, I mean, what I was going to do is generate the entire connector with that, and then put the 3D model onto that, and then update everything, and then add it to the schematic, because that would have been the fastest way for me to get that part in. We can generate our own, I suppose, by going into Fusion's package editor, which should have its own set of comprehensive tools for us to do that. I would hope that it would allow us to incorporate that 3D model, but I've never done that before. I did it kind of the cheaty way. Let's go into Fusion's package editor. I mean, I could just find like a 3-pin 1.25, or not. What do I have in my own library? Yeah, just a couple chips. The rest of this, I don't know why all of this stuff is associated with me, because this is all just stuff that I don't I don't have models for. All right, so we're out of library IO. That's not going to work out for us. So here we have this device. I need to create a new footprint for this thing. So this would be the Hyros DF3 3-pin. I don't know if I need to give it a different name. What, B dimension? What? 3-pin. I don't know if giving them the same name is a bad idea or not. All right, so here we are in the pad editor. Here we are. Create. I guess it would be a PTH pad, a round one. And then the size of it, this says 0.6. We want 0.35. How'd the fan to radiator adapter turn out? I managed to get through the prints. It shifted a lot. It shifted a lot for the print. And I guess, I don't know if it's just my printer either running into its own mistakes, or maybe I need to grease the Z-axis. The Z-axis is just freshly greased, right? So the shifts were weird. The only thing that I can really figure that it came down to was that the wiring for the Z-axis might get into just the right spot where it skips some X steps and thinks it's somewhere else. Because one of them shifted to the left, another one shifted to the right. And it's all on that X-axis. But I think those X-axis pins maybe need to get a better connection, or some dielectric grease, or just something to protect them. But this turned out really well, and I think it's going to fit on the final build. I don't think I need to space this out any more than it already is. My only concern is that the power supply does not buck up against this. I'll have to get that annoying 600-watt power supply that I have with all the cables attached to it and put it into the case and test it out. But this turned out really well. This is like really well. Really well. This is really well done. I'm going to pat myself on the back. Now, this works perfectly fine, and I'll be able to just suck air through the side of the case. The reason there's another one on this side is because the hole in the case is a 120-millimeter fan hole. We managed to sneak a 140-millimeter fan onto it because it had the rounded edges. So yeah, this will fit, and this will be the primary radiator. There's going to be 2 radiators on this thing, because eventually I'm going to be moving the graphics card into it. The 1080 that I've got into this. Although that's looking less and less promising, because the stupid 3090s are the 3080 and that series, they're 340 millimeters long, and the computer case that I'd want to move it into is 300. So I am a mite concerned that modern graphics aren't going to fit in my case. But yeah, that worked out really well. I mean, it was a little bit janky. I expected it to be a lot easier than it was, as is with most of this stuff. All right, so what hole are they talking about using here? Let's go to where they talk about holes. Let's talk about holes. They really want a 0.6, plus minus 0.3. What the hell kind of surround do they want on that thing? They don't really say. You bastards. All right. All right. All right. All right. All right. All right. Now, if I place the hole, I don't think it's going to go to T-place layer. So if I place this and it's 0.6, one of them goes there, Now, maybe we don't want auto on that. Control Z. So let's place a through-hole pad. All right, what do you guys recommend? The spacing for this, in order for it to fit within the parameters of Seed Studio's process, is that it has to be 6 mil apart. So 6 mil, our measurements are in millimeter, right? Yeah. So I need to do 6 mil. Oops, MMD. I don't know, in millimeter. 0.1524. So they need to be 0.1524 apart. Wish I had more measurement tools on this. And the pin spacing is, oh my god, I need a drawing for this. I'm gonna do MS Paint. Actually, I could just do it in the design thing for Fusion. New design, new sketch, put it on this plane. All right, zoom way in. So we've got our hole is 6. No, 0.6, 0.6. 0.6, and then that is going to be 1 1/4. Yeah, 1 1/4. We'll just do it in this direction. 1.25. The construction lines and stuff don't matter right now. 0.6. And so we need weenie. 0.1524 spacing between the lines that we create. So in the middle of this, let's do a rectangle. Just do a center rectangle. I wish there was like a mirror line command. 0.1524. And then measure from, oh my god. Now, which dimension are they asking for? When they do the pad, am I doing from the edge of the hole out or what? That's what I got to figure out. So if I take this and hit the, oh, it doesn't need to be a construction line. I go from here to here. That's 0.549. Or am I measuring, well, I guess I'll find out, because if it's not, then 0.249. So 0.5 something something is about the size. So I go back to the pads, place the through hole, place it, make the outside point, well, 406 I guess is close enough. I can probably put my own number in there, but I'm not going to. All right, so put that there. Is that not, what's going on with that? Can't place. Oh yeah, so it is the outer, like the overall outer dimension, so I need twice 0.5. Yeah, they're overall outer dimension. Okay. I can do this. So we're doubling that number, right? Create and recover file failed because you still have a tool open. Well, just fucking close it. Jesus Christ. Here, all the way out to here, 0.549, so 1.1-ish. It's not pricey at all. It's $5 for 5 boards under a certain size limit. Yeah, the places that make your circuit boards, they do it in a batch operation, and it is a wonderfully streamlined process. Why is this registering a thing? Why do I have $1? Okay, well, that solved that, hitting the delete key. 1 point, we'll do 016. All right, so there, we figured it out. Man, that was easy. God damn it. What is my grid? 1.27, 1.25. Bop, bop. Let's, can I measure? I can't. That's just amazing. Properties. negative 1.25, 0, positive 1.25. All right, there is our holes. Look at them, they're beautiful. So we could use their dimensions to figure out what the outline of this thing should look like. Yeah, even custom. What we're doing, see, the reason I'm being particular about these holes here and getting them right, getting them under a certain dimension, is so that there is a certain amount of space between them, because the PCB manufacturer can only create the etching of the copper at a certain size, there's all kinds of parameters that go with this. You can download a file that has all that information in it, or you can just copy it from the manufacturer's website, what those parameters are. When I say we need to be within 6 mil, it means that if I put lines that are closer than 6 mil, then that cannot necessarily be reliably manufactured. So when the spacing of 6 mil here, I'm making sure that those pads are that far apart so that I can be certain that they're not going to be connected to one another. Library.io failed us in not allowing me to create pads that had good spacing on it. Not to mention the fact that I couldn't measure a goddamn thing. So, Hardcore, thank you for following. I really wish that all these tools, all these layout tools, were available to us in this other section of Fusion. Because what I've done now is basically told it to make a circle that was, what was that size again? 1.016. It's kind of a crazy number, but hiya from Russia. How you doing, man? Thank you for checking out the stream. I lost the number. It was 5.015, right? That was definitely not the number. That was definitely not the number. Sorry, 1.016. So if I have that hole, and I'm just using this as like MS Paint right now. 1.016. And then the one next to it, obviously we already know. Like that. And then we lengthen this out. And then we give it a circle at the end, just right in the middle. And there you have it. I have now managed to draw a penis out of this. So cool to see content on Twitch. Yeah, look at this content. I drew a penis. Yeah. Look at him, master engineer. This is the kind of shit. Anyway, so... Dick move, oh bother. My boss walked by and now I'm homeless. How dare you have fun on Twitch? Yeah, the problem is the only like centerline thing that's like intuitive and quick is that center box. It's the only, like, I can't do like an immediate mirror line from like directly from a tool. So no, it's a guy carrying 2 water bottles, like the big jugs of water. Anyway, so yeah, that gives us more than, this spacing right here is 0.6 mil. That gives us more than 0.6 mil. Gives me a little bit of pad to solder to. I should be able to do well. It's a deep rock worker. Rockin' Stone. God, I need to play more games on Twitch. I need to figure out my game setup and make that a little bit more intuitive. Okay. So far, so good. Now, this is typically where I'd pull up a tutorial on how to do this, because fucked if I know how to lay any of this stuff out properly, because we need to give it name and value and all that stuff. The like greater than name and value. We need to put it on all on the appropriate layers. So the T place layer, the T position layer, all that stuff. We need to get that sorted out. Now, since this is just a silkscreen layout of where this device exists, then we need to figure out the dimensions of this device as it lays flat. And I love how they just don't give it to you. It's like they give you all these weird numbers. So for the height, 6.4 with a thing plugged into it. I don't know if I need to include the thing plugged into it, right? I mean, I might. Maybe I will. Well, first things first, we need to get the dimensions of the actual thing. Oh boy, they're dimensioning it off of the holes. 4.5 plus minus 0.2. We'll just take it at value. We won't do the plus minus. So 4.5 ahead of the pin what is behind that? We got to subtract it from that in order to figure out where all that stuff is. Son of a bitch. Where's the PS4? I'm not going to stream from a PS4. I don't have one. Well, we've got our center point. That's what we're basing everything off of. In order to draw the outline, we need to go to... Is it the dimension or is it the place layer that we want it on? Dimension or place? That's what I'm wondering. If we've got like our PCB design, that's not the one I wanted. I have so many windows open right now. That's not what I wanted either. I really wish I could just have this 3D design to overlay onto it. That's sort of what where the power in this software comes from, but I can't do it with this one. No, my Windows. The software hates me. Okay, here. That's the one I wanted. The two-dimensional PCB drawing. So the layers here that I have to choose from, I kind of want to base them off of other parts to make sure that I get everything in the right spot. You can see here that there's a dimension and a place layer on this thing. If I view T-place is there, T-dimension, nowhere to be found. T-dimension. Oh, it's just a generic dimension. Yeah, dimension is the outline of the board. So it's T-place and T-origin. If I don't view T-place... Okay, all right. T-names, T-values, those are totally different things. T-test. Okay, where's the... Huh. I thought it would be T-place. But that's not it. I mean, that is a lot of the other stuff around here. But, like, this part is weird. What dimension are you at? Document? No, not document. T-docu. No. Yeah, T-document can sometimes contain stuff like that. We're not really worried about that kind of stuff. T-map? No. T-plate? No. We're getting into the weird ones, though. T-silk? No. Test mark? What layer are you on? Oh, that's so weird. That is weird. Not unrouted, not dimension. Not place. Not origins. That's only the origins is just little cross marks that tell you where the part is. Names I already unviewed. Values? No. It's none of the stop layers or anything. Not the test layer. Drills, holes, no. Measures, no. Document, no. Patch top. It's not the V-score layer. That would be ridiculous. T-map, name, plate. It's got to be one of these, right? That's so weird. I can't figure it out. Where did they put... Themes, values, is it? Oh, wait, you know what? It moved to the bottom layer. That's okay, I'm dumb. I'm dumb. I moved it to the bottom layer. That's why it's blue. That's why it's not in any of the T's. Duh. All right. So it's probably B place. Yeah, one of them is B place, and the other one's probably, well, it's not dimension. It might be dementia. Is probably why I was unable to figure that out. Bottom names? No. Bottom something or other. That one. Probably not B test. No. Measure document reference. B docu? Yeah. Okay, so so for some of these parts, they're on the document layer for the layout of the component itself, right? That's on the document layer. and then the other one is on the place layer. So the place layer looks like keep out dimensions, and then the documentation layer looks like everything else. So the documentation layer does not get sent out. That doesn't get printed. Because on these parts we didn't have, yeah. All it has is like a little outline for some of them. So that's all good. What I can do is put them in the place layer because I want that outline. I want that outline. I don't necessarily need to do the outline, but I probably should just be nice and put the outline around the connector properly. Okay, so back to where we were, which God knows where that window went. Not that one. Not Untitled. I think it's, yeah, we're still in the, okay, we're still in the editor. Groovy subbed. Dude. Damn, where's the time going? How many? 32 months. Holy shit. Groovy something. Thank you so much for subbing. Let's put you up on the board. We're putting all the work in on the PCB for the RC car. It's maddening, the process of getting these parts in there. Once we get it all in there and documented, at least we'll know what we're up against, right? And hopefully the three-dimensional stuff lines up with everything else. Where's Groovy's? Come on. Come on, Twitch API. Give me that sub. Ooh, it's trying to place your name. Uh-oh. Oh, there it goes. Oh, that probably took several 100,000 tries. Really hope my keyboard works. I didn't do anything with that today. I was going to test it out, but I never got around to it. I'm worried because I spilled something on it, and I guess I don't remember spilling something on it. So I woke up this morning, not this morning, yesterday morning, with it covered in something. The keys were dry. Just the substrate had been sitting plugged in overnight. So I had to do a comprehensive clean out of everything, and then it worked for 5 minutes and went back to not working. Groovy something, you're up by salad gravy. It's too hot outside for my name. I know, it fucking sucks out there, doesn't it? I went and did a couple errands before stream, and holy shit. You're up by Larson Dog. And hurry up Grandma too. Wasn't that Schmide? Didn't you gift that one, Schmide? Who do you use to make your PCBs? I'm thinking about using JL PCB, but for now, I use Seed Studio because they make a professional board for $5. And then, of course, the dividends go to DHL. But DHL is a really good shipping company. I mean, they're really good at what they do. So I'm not that disappointed in giving them. I mean, it's still like $30, but to get 5 PCBs for like $40, that's a super duper good price for like pro work. So just went to Goodwill to check out their old CDs to add to my collection. My car's outside temp thing said 100 Fahrenheit even while driving. That can be deceptive because the blacktop tarmac really heats things up. Like the what your dog feels temperature is insane. Like if it's like 80 degrees out, your dog could be putting its paws on like 90-degree stuff. Like you gotta keep those puppies on grass, you know? 92 feels like 104. 60% humidity. Oh, that's fucking torture. Around here, my worst experience was in Maryland, where we had 100-degree heat at the festival, and I had to work outside. I had to bury a bunch of like fire lighting, like supply lines and stuff, and you know, so we were sitting there like dredging and post holing and stuff like that. The air wasn't moving. The air wasn't moving at all, and the humidity was extremely high. Like literally, like we're in a field and none of the trees are moving. And it's like, how is this possible? You would think this field would at least have like a natural convection to it. Nope, nothing. Right? That was in Maryland. We're working, and I just felt like I had the flu. I was like, what the fuck is going on? Like, did I catch the flu? Like, I am so tired. I'm so, like, I can't think straight, et cetera, et cetera, et cetera. And they're like, you should go to the medical tent. I went to the medical tent. Glucose levels were, like, super high, right? I wasn't able to inject insulin and get them to come back down. I didn't have exactly this equipment back then either. So they were like, who cares about the glucose levels? You don't have electrolytes. you need to drink this Gatorade. It was like, I was drinking water, and like I just felt super weird. Turns out, I sweat out all of my electrolytes. So, you know, Brondo, I needed to have Gatorade, 1 bottle of Gatorade, but I'm like, this has carbs in it. And they're like, don't worry about the glucose level right now. Drank it. Piece by piece, all of my body's systems started coming back online. It was like my head cleared, and then I had to pee, and then I started sweating again. Like, one by one, they came back, and then I was able to suddenly take a hold of my glucose level. It was crazy. It was absolutely nuts. I've never had low electrolytes before. This sucks. I need to plot out the location of all this stuff. I guess I could do it with this drawing. My beautiful penis drawing. Take that, go over here. I don't know why I need to do this, you know? This is all within the same, what kills me is this is within the same software, right? I've got this extraordinarily powerful layout tool. If I could assign layers to lines in the other piece of software, that'd be perfect. Same thing happened to me at some Hippie Fest, PA, north of Hancock. That's a great town name in PA. My friend looked at me and said, get in your car, turn on the AC, and come back in 30. I had the same experience in, that was another Maryland. Maryland sucks. That was another Maryland thing. I was working with friends on a Le Mans rally. And there was a point where they were just like, dude, you look rough. Just get in the RV where there's AC. And I sat there for a minute and I was suddenly just like ding, oh, I'm better now. Yeah, it's all in fucking Maryland. Apparently, when I go to Maryland, I get heat stroke. I have a thyroid condition. It's amazing how out of whack the body gets when that is off. Yeah. I had to start taking thyroid meds because I was on the, I was borderline, and my diabetes doctor was like, there's a chance that you might get like thyroid cancer. So we're going to give you an MRI. So I had to have an MRI, which is stressful enough as it is. So weird. They're measuring the atomic spin of my brain while my brain's busy being my brain. Weird. I can sweat through a shirt in 3 minutes. Challenge accepted. You're on. What kind of crazy person would live in Maryland? I know. Total hellhole. You get heat stroke there. 1.016. I was partially saying that to not to trigger Groovy, but yeah. I have a friend that lives in Maryland. The state is meh. I like Maryland. Come on. My brother's from Maryland. All right. So we got that. See, what I'm trying to do is the way that stuff is laid out in the component layout thingy, I don't get to drop construction lines on this. Everything I'm doing is based on a coordinate system, which is why when I was trying to find the location of these holes, I'd right-click and go to Properties, and then I'd look at Position right here, 1.250, right? That's what's going to define the locations of all the stuff that I'm trying to lay down. Trost de Goss, thank you for following. I want to put a box around our component so that we know where it is, right? At least we have decent beer. Hey, man, the whole Northeast is decent beer. Probably the whole United States, to be honest. We're good at making beer. Everybody gives us shit. Like all the Europeans like to just poo-poo us all the time and say like, yeah, but Bud Light is just water. Well, yeah, it is. It is. Like our grandparents drank really shitty beer, but we figured it out. What has Bud been dethroned about? Bud had a throne? Smaller brewery or Louis the Marine. Europe is trash, and I live in Europe. No, I'm not saying that. I'm just saying they like to try to give us shit for like things like Bud Light, and we're like, we didn't do Bud Light. Bud Light is a European beer. So anyway, this piece of software here was incorporated into Fusion 360, except, and I don't know why, there are some really nice layout tools that exist within Fusion Eagle, but there is a much, much more powerful set of software for doing two-dimensional layouts, and that is Fusion's drawing tools. They're really good at what they do. You can drop construction lines, you can drop regular lines, etc., etc., etc. That's the way that I believe that Eagle should do it, but Eagle's always used this method and these tools. So we're back to fundamentals on that. And unfortunately, we don't get the high-powered layout software that Fusion has incorporated into it because they wrapped this software in there and they didn't change a whole hell of a lot. You've got these remnants of the old software that still exist. And that's sort of annoying to me because a lot of the Fusion 360 stuff makes it very easy for me to operate within, you know, my thinking has kind of, on how to lay lines down, has kind of catered itself to Fusion 360. Budweiser Walmarted all the small breweries 50 years ago. I think it was like people just didn't consider that they could brew their own beer, right? It was like, you know, there's a big explosion of that like 15, 18 years ago. Probsco, sub to the Prime for 2 months. Hey, Probsco, let's put you up on the board. So anyway, I have to deal with coordinates in this. I don't mind Budweiser, but calling it, you know, like comparing it unfairly to good beer is annoying to me. And when people say, you know, people blame America for Budweiser, and it's like, you got to know that that's like, it's not what you think it is. We don't do that. All right, we don't need that. I'm going to leave this because that failed us. All right, let's put Probsco up on the board. Thanks for joining me on a Wednesday, everybody, by the way. I didn't stream yesterday because it felt like a piece of shit. I figured I would be doing this stuff anyway today. So I wanted to bring you guys along on the journey with me and deal with the frustration of everybody thinking I need to use different CAD software because I'm doing just fine with this. Probsco, you're by Cilia. And whoever Mia Khalifa is. Mr. Drill Bits over there. Trey Pop, McAndrea, Undead Leech. Sam Adams here in Boston is good. I once got Sam Adams, and it was this friend of mine. He's actually in the Discord now. This friend of mine got like this insanely, like, I don't know how to describe it. It was like a porter, but it had so high of an alcohol content that it was more of like a liqueur than anything else. I took a couple sips of that and I was just like, I don't know about this. Sam Adams is okay. I don't know. I like my craft brews. They're not hard to find. Although the IPA trend has ruined craft brews for quite a long time. It might have been an imperial porter, but it was like a syrup almost. I don't know what the hell that stuff was. It was a long time ago though, so I don't know. Maybe the memory is distorted a little bit. So, all right, let's see what dimensions I need to put in this thing. I had a really nice Belgian triple last night, and it came with a little cup of Gouda chunks that you could pair with the beer. It was hilarious. It was like liquor strength. It was like 10-something% alcohol by volume, and you didn't feel that alcohol kick if you had the Gouda with it. How was it, you ask? It's pretty Gouda. I'm so sorry. All right, anyway. I had Voodoo Ranger on tap. Ooh, yes, good stuff. 9.1%. Oh, man. Gouda's fucking lovely. It was a little waxy, but it offset the sort of like chemical triple flavor, you know? Because you get like the berry and the sweetness of the triple with that sort of like chemical twinge at the end. And if you have the cheese, the sort of waxiness of the cheese kind of balances it out really nicely. Dewey left. All right, never mind. It's all over. All right, so from the pin, we got to go 4.5. I'll do it in a construction line. I'll do construction lines just because. I really wish that this would translate over to the silkscreen layout, right? It just doesn't. All right, so 4.5. Really, 4.5? That's huge. That says 4.5. That is enormous. All right, 4.5 forward. And then we go I guess I could measure it off of the part too if I really wanted to. 5.4 overall. I guess I can come back from this line. Oh, good. It put an angle on it. Control Z. It's kind of weird, but I don't know. I guess it works. 5.4. And then our side dimension is, and I'll do a center square for this. And that'll help me get the coordinates that I need in order to create the lines. So we're going, I mean, 6.4 is with a connector. Without a connector, what is our width? Our width is C plus or minus 0.2. That would be 5.4. Oh, it's the same thing. So if I do a square from the center of the 5.4 line, should be the first one that I get to. 4.5 is there. 5.4 is here. Oops, no, shit. Center square, rectangle, center, non-construction. From here, up. I missed. Great, rectangle, center. .4, 5.4. That is our connector. Voodoo Ranger's 7, one I got in the tall can at 9. Go buy another one today. Google, why are you lying to me? What's going on with that? Did they read the wrong number? I've had that happen before. All right, so the box that I want to put around the thing looks like this. I could do the connector plugged into the end if I really wanted to like put a detail in here, but I think I'll just leave it like this just to keep it simple for now. So now I know the location of the coordinates because we know this is 0, 0, and I could literally just take a line. Actually, it'd probably be better to take a square, go up to the corner, and I know the first one is 2.7, 4.5, negative 2.7, positive 4.5. That's how I'm cheating this in order to get the dimensions down without having to do too much math. That's basically the entire motivation behind this. So I am going to not dimension, I am going to place, T-place. Was that where we were going to put that? On the place layer? No, because the place layer is going to get to the silk screen. Yeah. Pad array. See, it's got all these tools in it, right? SMD pad, PTH pad, pad array, name, line, text, hole, pattern. All that good stuff should probably have been imported into this drawing tool, because this drawing and layout tool is so much more powerful than what is included in Eagle. And it would be nice to have that cross functionality, and it would be nice to have the feel of it and the same tools in both. So I could put construction lines all goddamn over my pad layout and have that render into the pads and at the different layers, and then still have the ability to go back and tweak and tune. But I don't. All I can do is make this drawing as sort of a crutch. The fools! How could they not know? All right, anyway, so from here, I'm going to negative 2.7, 4.5. So I'll go here, I'll create a line, any old place, properties, and then this one would be, oh God, where is it from? I have to do line layouts. Instead of doing that, let me just draw the box. That'll give me a better idea of where everything is. I'll just draw a generic box, and we'll just go around this connector, and that'll give me sort of an idea generally. Oh God, that was terrible. That was absolutely awful. That was absolutely terrible. I did a bad job. Yeah, it's treating them like circuit board traces. Oh yeah, look at that. Look at that derpy little guy. Properties. So that's actually correct. And then the upper one was 4.75. I'll double check that. Negative 2.7, 4.5. Oh man, I got that really confused. 2.7, 4.5. So this one would be positive 2.7. Jesus, where does this go? Is this one? 4.5? And this one's 2.7? That might not be right. It's not! This is messing it up. That's gonna mess it up. Well, I think that's needs XY labels in the dialogue. I know. This is kind of annoying, isn't it? That one needs to be positive 4.7. Okay, let's just get the bottom one in. I'm just skipping it so I can do another one. So from here, 2.7 minus 0.9. Cosmo Crest rating with a party of 31. Hey, how you guys doing? How's space doing? We're doing the weird stuff here with RC cars. I'm trying to get all my brought some friends back with me. Hell yeah. Thank you, Keeper of Maths. The layout that we're doing right now, see, Fusion Eagle is the software that has PCB layout and mechanical layout in the same software suite. Eagle used to be a different program, Fusion 360 was a different program, and then one bought the other, and they all got together and became Fusion 360, Eagle, AutoCAD, whatever. So I've got just this layered software that I kind of need to sort through in order to create a component. And the component we're trying to create is a little tiny 3-pin connector. But in order to get the silk screen, which would be the thing that tells me the dimensions of the part, there's like a layer on this called silk screen. All right, well, I guess that's good enough. Ooh, the microscope is not coordinated. This is a bit of a mess, but you can see that there's a white layer on this circuit board where stuff is printed, right? And that white layer of stuff is the silk screen layer. And what that does is that relays information to me while I'm laying out the components and while I assemble the components. It tells me what goes where, essentially. So what we're doing is we are trying to lay out the dimensions of the connector, because the ones that I used previously are way too big. You can see the size of these things. We're trying to put this connector into this little cubby hole here on the RC car. This little tiny area right here that I want to put that circuit board into. And so what I've been doing is I've been modeling all of this stuff in this software. I have a comprehensive 3D model of the actual toy car chassis. I'm going to cough, hold on. The toy car chassis. I'm going to call it a toy, even though, you know, it's more of an adult man-baby toy, so that I can entertain myself during what is ostensibly going to be another quarantine. I'm getting a little pissed off at that. So I'm trying to make a circuit board that goes in this space. In order to do that, I had to mount a different motor properly. I had to reverse engineer some of the parts and figure out their dimensions, including this differential housing. I had to recreate some parts which had errors in them, like this piece had some holes that were drilled in the wrong location, which is ridiculous. And I think they ordered a wrong bearing that goes sort of in here. And it's hard to see where the bearing is. The bearing is inside of this piece all the way in here. There's a little ball bearing there that hits up against the spur gear. There's a meteor shower that you guys were watching. Oh shit, that's awesome. You guys are the only way that I really keep up with this kind of space news going around. But yeah, so we had to correct some stuff that was wrong in the original wltoys kit. I modeled a bunch of this stuff by reverse engineering the dimensions, and now I know what is all in the surround of the circuit board where I want to put it. Because I want to put it in here because it's a challenge. This is a cool little challenge to try to get the circuit board to fit sort of snugly above the servo. I'm excited about that. I think that's kind of a cool thing. So what I've been doing is branching out into the circuit board design facet of this software. We're discovering all of the varied and unique ways that this program is limited. And one of them is that the dimensional layout stuff that I have to do in order to create that silkscreen pad for the component that I want to put in is fairly limited. We need that component because I need to figure out where all the stuff goes. Without that, I don't get a good render of the PCB. I get this crazy shit. It's all over the place. So I've got the connector from the company that makes the connector. I don't have the pads, and I don't have the outline. So I'm using their tools in order to create the pads and the outline. That's where we are. That's where we are. Properties. So this needs to be negative 0.9. Or no, negative 2.7. This needs to be negative 0.9. This one needs to be positive 2.7. This one needs to be negative 0.9. I need to fix whatever the hell I did over here. Properties. That doesn't look like 4.5. Negative 0.9, 2.7. From 4.5, 4.5. That needs to be... What does that need to be? 4.5, what was it? 2.7, I guess, right? So from 4.5, 4.5 to 2.7, negative 0.9. That would be here. That would be the run. This one needs to be 2.7. Oh, Jesus Christ, I got it right. Thank God. All right. That was nerve-wracking. And the reason that I was able to know those coordinates is because I used a different piece of the software to do a dimensional layout, which I wish I could do on the part that is responsible for the silkscreen. All they need to do is expand the sketch palette so that I can have varying sized lines in addition to construction lines and, build lines. Because this thing works in creating solids. So I could extrude this piece that's been defined by my lines. That's what this layout software is for. You could tweak that a little bit, and then you could make it just as powerful for silkscreen layouts. I would love that, because the ability to inspect stuff and get everything just right would be powerful. It would be powerful. All right, now name and value. I don't feel like I need to put a name and value on this thing. I never really do that with my components. I think just for the sake of showing the process, I should probably do that. So I can go down to the, what layer are we putting that on? We're putting that on the top value layer. Not value, top name. We'll put it on the, because there's a name and a value. So C1, R1, L1, that's the name. And then the value is like 10 ohms or 11 ohms or something like that. And it's probably, in my mind, it's bad practice to put values directly on your silkscreen, because sometimes you tweak stuff and then you'll get like, oh, I said it was 5 ohms on the silkscreen, but it's actually 3. Like that's very little ohms. But anyway, that's sort of the thing, is like, plan for the future. Don't put values on your circuit board unless you're making a very basic kit for somebody to put together, like for a kid to put together. You shouldn't be printing the value directly. Yeah, or you just put or you just put completely wrong values, and whoever's reverse engineering it is like, what the fuck? So top names, top men, and then are we doing J? So I'm just going to create text. And let's see, how does Fusion do this? I think it's with the greater than or less than. Let's look at another part and see what happens with that. I just want to get this part right. No, no. No, that's the wrong one. It's the wrong one. That was also the wrong one. There we are. So when I place a component, actually, I place it in the schematic. Well, let's take a look at what these will already be driven to have, so T names. So I'm wondering if it's like R $1 or whatever. Because this has pad 1, pad 2. So it'd be pad $ something or other. We need to look at it from the schematic thingy. If I place a component and I go to my connectors, why are there 2? This is really annoying. Version 43, I guess, is the newer one. I don't know which one I'm working in right now, though. So, yeah, G $1 and then greater than or less than value. Yeah, I'm not putting in the values, so. Name value. G $ value. What sets the name then? Like it's $1 and then name and value tag. All right. So I'll just do J $1. Where are we? We're in, oh my God. I believe it's this one. Yep, there we go. So let's add text on the T names layer, and it will be J $1. What the? Okay. I hit wrong keys and everything went haywire. J $1. Oh dear God, it's enormous. And then we want fixed font, proportional, or vector. Let's check with the internet on this one. Fonts. The 3 main fonts that we use in the library included serif, sans, and mono. Each font is available with a few styles from 9 point blah 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 blah. This is not what I was looking for. Terminal LCD fonts. No, that's not what I wanted. Fusion PCB. Control F. Font. Minimum size is 6mm line width, 32 height. Bigger will be better. It's not. That doesn't tell me much for the type. Font type. The studio doesn't accept Eagle board files. Let's write short guide. Use PCB at its best. That's all right. Yeah, that should. I just want to know what exactly type, you know. Well, no, because it'll change when you order the board. See, Autodesk hasn't updated their fonts in the past 2 decades. Yeah. Fixed or proportional is just cosmetic. The font size will change on you if you don't choose the right one. Vector auto scales, is that the one? We're sending those seats to suggest check the content with a Gerber editor. I do that. Yeah, experience sometimes found error, export files. So use proportional fonts, they may change size. So as long as we don't use proportional, which is what was selected by default. Thanks. Just fixed. Oh God, it's hideous. Font family, Arimo. I guess that's and so if I do vector, I still don't get to choose. Yeah, vector is the ugly one. Actually, none of them let me choose, huh? Custom is probably, yeah, that's the. Then I can use all kinds of cool stuff. Now I'm just gonna make it I guess we'll do fixed. That looks really weird. Sure, that works. Line distance, angle 0, character map. Yeah, we don't need to worry about any of that stuff. Not using wingdings. That doesn't really matter where I put that. I'm not really going to be using it. Okay, so that's it. So I can save that footprint. The hard part is going to be getting this to match up with the layout. I think the layout I centered on something else, but manage libraries, local changes, to upload these changes, push changes option, manage toolbar menu. We don't need to worry about that yet. So, all right, so that's our new footprint. We need a schematic symbol for it. That's easy enough. Actually, I don't need a new symbol name. We can use an old one. We use a different one. It's just like a 3-pin header. We just use whatever 3-pin header symbol we can find. So, all that said and done, do we have a component? I don't like how I can't get back to the footprint manager from here. All right, I guess I just gotta wait. Take your time. It's not like anybody's waiting on you. I don't know if I should be uploading it or not. I'm just doing it because I want access to it. This process needs work. It needs work badly. It's not as open or intuitive as the rest of the software is. It's a holdover from adding 3-dimensional parts, etc., etc. Yeah, there is version control. Yep. I mean, it's a little haphazard, but yeah, I do have a version control thing that I can do. All right, so we need a new component in here, right? Unless I already started it. I'm waiting for the software to unfreeze itself. Can I? Okay. Okay. Whenever you're ready. Alt-M. Get me on the board. Alt-M subbing for 4 months. Alt-M, you got it. Sorry, it's @M. It's not Alt-M. I don't know why I put an L in there. I'm a little tired today. Adam, let's put you up. Well, whenever the Twitch API decides that it should, do anything, whenever you're ready, it's cool. We don't, we could just wait. Okay, there it is. @M, welcome to the board, man. Thank you so much for subbing for 4 months. I still need to do an actual emote day. Our emote day got interrupted. We probably should have animated emotes. Probably. @M, welcome to the board. You're by Groovy something. Coolig. Art Splunge. A little spot right there. My emote's arm looks cut off, even though it's not supposed to be. Did something change that made it a little cut off? Or did I decide to cut it off like that? I don't remember. Bald engineer. I was going to say bad engineer. No, this guy's a good engineer. Bald engineer raiding with a party of 42 people. Hell yeah, dude. How you guys doing? We just put somebody up on the board. We're doing a little bit of Fusion 360 over here. So I've been yelling at software for quite a little while. Both are probably right. No! Bald engineer, thank you so much for the raid. How you guys doing over there? What's up, what a weasel? Yeah. So we've been working at Fusion 360 and having kind of a chill day where I try to wrestle software into doing stuff my way. We have been working on a tiny RC car, as you can see here. What happened to the... Oh, good. That finally came up. All right. The tiny RC car, which is the wltoys 989 kit that I have been extensively 3D modeling for the sole purpose of being able to run a 130 sized motor, as well as putting all of the electronics into a little cubbyhole space that exists right above the servo. So running this and changing the servo type have netted me a little bit of extra space. I even modeled the battery, which is just all you do is you make an oval on either side and extrude that inwards, and it makes enough of a placeholder for a battery that it kind of looks like a battery that's been shrink wrapped. But this model, yeah, this model took a lot of effort. I mean, modeling this differential casing was an absolute pain in the ass. This thing is a bunch of drawings in one, getting all these dimensions exactly right, and then discovering midway through that the holes on top of this bar right here, those holes right there, those are not in the right place. You can see here, they are much closer to the edge on this piece. This piece was not manufactured correctly. This is in the right spot. These are in the right spot because they've got that even radius around there. But back here, as compared to the original, they are not in the right spot. See? Even radius to the outer edge. Not even radius to the outer edge. And so that caused a cascade of mismeasurements on everything. In addition to the fact that the bearing that they used on the motor mounting was 2.5 millimeters wide, but the design called for a 2 millimeter bearing. So even in the stock kit, things are assembled just a little bit wrong. I guess they figured they could just go forward with whatever in order to make the RC car. Flipjoy, thank you for following. So yeah, I've been working with this 3D model for quite some time. It's moderately simple. Basically, you take all of these disparaging elements, all these quote-unquote components, and you take them into their own drawing, spend some loving time with the calipers in order to figure out what the outer dimensions of these things are, do an extrusion, tweak and tune, do some chamfers in order to make it look nice, and then pull it into the main drawing. The wheels I already had modeled. The spindles and the A-arms were fairly simple because all the weird numbers that I came up with rounded out to normal millimeter numbers. Because nobody's messing with that kind of stuff. Is the whole car 3D printed? No. No. All that modeling stuff is just to make sure I know where stuff is. So I have carbon fiber bars and stuff, and then the metal parts are actually metal. I didn't bother to do the ball joints or anything. The 3D printed stuff is what is mounting the servo and then the motor. And so this is sort of the latest version of it right here. So these are just about as small as my 3D printer will allow to be printed. They don't quite fit either. I need to make this a little bit more narrow. Yeah, no, this is actual carbon fiber, and all the holes are in weird spots. I had to spend a lot of time doing a lot of different measurements in order to get my my proper datum points for everything to make sure it was all good. And actually, as a result of doing this, the primary axle is much more loose than it used to be. It's actually really, really good. Whereas the wltoys kit, as purchased from Amazon, had that wrong bearing in here, which puts a little pressure on it and makes the drivetrain a lot more, I don't know, it's like locked up. It's a gummy. So that's what we're working with. And what I'm trying to do is take my circuit board, which is the radio receiver, that's this piece right here, the gyroscope, which will be really fun to use if I can get it to work. I think I have to buy another one too if I'm going to be building 2 of these. But yeah, the gyroscope, which does steering corrections when you're spinning and not telling it to turn, and the H-bridge motor controller, all wrapped into one thing, right? With a Arduino on the back. That I would like to fit in here. Now this doesn't fit quite at all, right? So I'm redesigning the board because obviously there were too many mistakes on this one. Redesigning that board so that it fits in this limited space. Can't do these connectors, they're not gonna work. Big capacitor, probably not gonna work out either. If we need it, I'm really gonna have to think about where I'm gonna put that. But that's the whole point of this 3D model and Fusion 360. I love the look of Fusion 360. There are still some things that lack polish, which is the method by which we are making a servo connector and trying to measure out all of the different dimensions of it. We have created the part. We've created the footprint. I can find a pin layout thing. We need to associate all these with one another. Oh my God, what is this? I've got a novel to read, hold on. Do you think there would ever be an anti-over-engineering trend before... What? Do you think there would ever be an anti-over-engineering trend? Before Tesla Motors, I like the idea of electric cars because of less maintenance and being less over-engineered. But every Tesla, now even ye old internal combustion cars, are loaded with super complicated black box software, shifting the point of failure from hardware to software. That's just not true. That's just not true. I mean, cars are, to a degree, they're built up on the foundation of what was there before, which can cause a lot of security issues in digital systems in cars. But, I mean, they're not going to put nobody is over-engineering something. If anything, they're under-engineering something. That would be a primary symptom of being under-engineered, because they need more engineering to come in and go, that's too complicated. We need to simplify that, or we need to rethink this, or we need to rebuild this from a standpoint of somebody who would work on the car, which is all getting into right to repair kind of legislation. But if anything, in my opinion, that's under-engineering, because you haven't brought in a systems engineer or a mechanic in order to evaluate that. I mean, that was the thing in cars, and the reason we have all these black boxes is so that your mechanic can plug in a digital device provided by Ford at a very large expense that will then say, hey, these parts have gone bad, or we're not getting a good reading here, or we did a diagnostic and this part is broken. And they can get right to the problem instead of saying, well, it's an electrical gremlin. Who knows? That's what all those sensors are for. All right, so this is the board layout, and you can see how it would function in free space. It's not done. It's not done. But I want to put my part down on this. Model T was designed to be repaired by its owner. Yeah. But it didn't do so well in a head-on collision. Where are we looking? We're all the way over here, right? Untitled is just my scratch pad because of the limitations of the software. All right. So, oh God, all these parts. Did I already start this? I feel like I've started it 1,000 times. But it looks like I did not. So I need to make a new, see, this is specific connectors. So if I have a connector from a specific manufacturer instead of just like a pin headers and stuff like that are my generic connectors. Those tend to like flood a library. So this library is mine, managed, meaning that it's uploaded to the cloud. And then I need to now create the component which references all of the 2D and 3D stuff that I had before. That's the problem with everybody being in a hurry. Head-on collisions. Yeah, man. So the new device name, Hyros. Oh, it was a D13. What the hell series is this fucking thing? I'm so sick of this connector. This should not take this long. The stuff that I'm doing is not very complicated in the grand scheme of things. And if I had better layout tools and more of a flow process in order to put this thing together, which is not that hard to do. It's a very simple thing. You go end to end on it and you end up with a part, right? But the problem is this has been convoluted. Eagle had their own system of doing things. Fusion incorporated Eagle. They did not rewrite that process. The AutoCAD method is drawing, extrusion, part, etc. Eagle is like schematic parts go down, arrange them on the board, and then they added a three-dimensional step to the end, which is when you can put mounting holes into your PCB and stuff. But that process, when you're putting your schematic together, you're expected to already have all of your parts ready to go. And in this case, the dimensions that we're dealing with, the limited amount of dimensions in this little cubby hole here, means that I'm going to be looking around and trying to find parts that will work in this design. So I need to find three-dimensional drawings of parts. But because of the process of AutoCAD, when you create a part, you create, what is it, like the schematic representation of the part, you create the footprint, and then that was it. And you associate those with one another and you connect the pins. Now you've added on to this 3D step. And so you have this comprehensive 3D creation software, Fusion 360. It's a little different. It's a little different. And so there's a little bit of jank in there. And that's what we're dealing with right now. Anyway, DF13. DF13 is a series. Hyros DF13. I want to keep that reference alive so I know what part that I need to order eventually. 3-pin. Right angle. You can't always just find the part that you need, right? Where did... Okay. That wasn't shown before, was it? Was that shown before? Was that there? We're going to have to delete that. Anyway, all right, we're working on this one. Jesus Christ. All right, we're working on this one. So I can draw the schematic layout part here. I feel like I should be able to import it, though. How do I add it to this part? There we go, that's how. All right. So MO3, cool. Hey, look at that. Pop that down there. Now we've got 3 pins. So that's all I needed to do. Ah, that's pretty nice. Sometimes things work out. I want this here, or do I want my origin point to be one of the pins? I'm gonna Control Z that. Let's put that back down. MO3, click OK. I mean, it looks like it already grabs from this location. If I really wanted it to lay out very easily, putting it like that would ensure, well, putting it like this would also ensure the same thing. So I'm going to do that, just to make sure that it sits down on the grid properly. I'm not certain, though. That origin point's over there now. Yeah, maybe we'll just do origin point to... Okay, let me Control Z that. All right, we'll just do origin point to origin point. This is one of the things that I kind of like need to make sure that you get right, especially the grab points for the footprint, because if the grab point for the footprint is in a weird spot, it can cause all kinds of problems when you're trying to lay it out. I don't really know how I'm going to do that. All right, we're done. Okay, so there's that part. So now I need a new... How do I do this? How do I add a package? Local package. Now, how come the footprint and the package... That's something that I think I need to resolve here, because I don't think that's going to work out. I've called these all Hyros. I think that's why I wanted to create it with a different piece of software. No, that's the variant name. HHIJ. Oh, geez, it really jumps off quickly. Yeah, they're not associated with each other. Did I need to... Okay, there's that, and it doesn't have a 3D model. And then I can go... Why are those X's around it like that? That's a little odd. I thought there was a new 3D package in this menu, but I guess not. How do I get into the 3D model of this and turn it into my own thing? That's the question. I got this guy sitting right here waiting to go, raring to go. Derive PCB from Sketch? No. Create 3D PCB? No. None of that stuff is really what I'm looking for. Manage materials, the App Store. Nest preparation? What? All right. All right. There's a way to do this. I'll figure it out. Hey, where'd my thing go? Socratic Paradox and Blipjoy, thank you guys for the follows. Yeah, we're in no man's land now, right? Because I can connect the pins. That's easy enough to do. Connect. Okay. There's my drawing again. I want to get into this. If I do a new 3D, but I've already got the old one. If I do a new 3D package, and I've already got that info, it doesn't let me import the pads like the other ones have. See, the other ones have the pads imported already, and they've got them laid out like a layer on this thing. That's why I'm like considering, that's why I wanted to start from these and just replace the three-dimensional drawing on it. But it put the headers too close to one another, and we kind of abandoned that. That's what I wanted to do, but all right, let's see. New local package. And if I go to, well, it does the wrong one. It doesn't allow me to do the three-dimensional one, right? Oh, you know what I can do? I can duplicate something and then replace all the pieces of it. Yeah, because it's like I created these like independent of one another. So how do I put them all together? You would think, and you would be wrong, that this tool would somehow help you do that. But it doesn't look like there is a place for me to edit the 3D package aside from having this square sitting over here. I think the way that I figured it out with the other one was by creating a part and then removing all the stuff. Yeah, I think that's how I need to do it. So, God, that is frustrating. That's really frustrating. All right, so I need to take another part and then eviscerate the stuff from it because I can't go into the 3D editing stuff. There's no menu for that. So if I go to an already established model, tiny car project type, yeah, man. Pins, pad, variance, description. So let's take something that's known and good. Let's delete that. Did it delete the wrong one? I don't think it did. Wait, I think this is where I added. Hold on. Edit, delete. Here we go. Attach copy of existing 3D model, create new. Oh, it was simple. All I had to do was go into the part, expand the tree, right-click on just the right part of the tree, and now I have attached copy of existing 3D model. Instead of in the other stuff they give you to... All right, attach that. Let's find it. That would be somewhere in high rows. There we go. God damn it. Can I not import it? I cannot import it? No. This is the frustrating thing, is that I can do new 3D model, and I guess... Okay, so what I can do is new 3D model over here. Yeah, it's like you got to find the right buttons in the right spots. It's just crazy. I thought I already did this, but I can take my... Yeah, because one of these is actually... man. Man, is this not frustrating or what? Take this over here. No, it's not going to let me do that? Here, no. Close. Oh, I probably have to save that before... Here, this we don't need anymore. Get rid of that. Manage library, we don't need to worry about. I'm looking for the actual, yeah, DF13 model. That's this guy right here. And actually, what I should do with this, I'm going to move this so that it's centered. It's centered on the pin that we centered the rest of this thing on. So I'm going to move the component from point to point. The problem is there isn't a point inside of here. Yeah, I don't really have a point inside of here. But I guess I can do the center of... Select that component. Go point to point. Center of this to origin. And then I'll move it down until it's just over top of the floor, I guess. I don't know where you put this the pad layout in this. I don't know how you associate that properly. It really needs some work. It really needs some work, doesn't it? I think it's just over, isn't it? Or is that clipping in? No, I think that's on the ground. That's where it should be. Okay. All right. Save that now that it's in the right position. Now that it's saved, I'm going to close it so it doesn't cause me problems. And then this is our component. Hopefully I can just do this. God damn it. Please save the design before inserting components. Really? And then for some reason the silk screen isn't represented in here. How do I add that? I'm confused. It'd be nice if I could actually get the silk screen in there. What if I do this from... All right, hold on. Don't save that. Just close, get out of here. I mean, I did that from there, and I told it to add that, and I've got this silk screen right here. What? The reference package is not stored in Fusion Team. Do you wish to copy the package to Fusion Team and then update the reference? I don't know. Sure. Yeah, do whatever, man. Aha! Wait a minute. Suddenly we've got the right thing. Suddenly we have the view that gives us the silk screen and everything. So now can I drag and drop this piece in? I can. All right. We're getting somewhere. Whatever just happened was the least intuitive thing that I think I've ever had happen in CAD software. I don't know what that was. How come right-clicking on it and editing it opened the three-dimensional interface? I gotta remember that for next time now, because it's so fucking ridiculous for me to have to remember, oh, you gotta click it just right. Otherwise, it doesn't work. It would be 1,000% better if they didn't try to shove the cloud down your throat. Yeah, it would be nice. That would be nice. Because I can't... A lot of my files are not organized properly. They're all over the place because of the cloud stuff. It's like, I would love to be able to manage a folder properly, but sometimes codependencies keep me from, like, deleting old files and stuff, just because I need to do, like, milestones with something, and then that all goes up to the cloud somewhere. It's like, oh, God. And if they try to change anything on Fusion and I have to get all my files locally, it's going to be a very long day of exporting stuff. I guess we're doing the same thing with it, huh? Negative 2.3. Should I have it a little bit higher than that? Probably not. I'll just take it down to negative 2.3, and if that causes problems, I will have to, I'll have to work on that a little bit. But like that, okay, so that could have been a little bit more intuitive. And they probably could have given me the pads instead of these weird dotted line outlines. There's some good scripts for export. That's right. Yeah, people. Yeah, when they updated the free tier, I hope they don't do that again. Fusion. Okay, so from my understanding of Fusion, they do really care about the hobbyists and stuff. Even though probably the lion's share of the revenue comes from like professional companies using the software. Because I mean, this is a pretty layout. This is very nice. Everything looks really nice. It's very presentable. For the most part, when I'm staying within my lane of what you're supposed to be doing with the software, it's easy for me to explain how to use it and stuff like that, right? That's what's great about Fusion. But I believe that the lion's share of the revenue is coming from big companies using their software, right? So their hobbyist level is not really necessary for them to conduct their business, but they do it anyway, and I think it's a wonderful service. It's a great piece of software because you can use it at its simplest form with the very complicated model. You have to get down into the onion layers in order to get to the really advanced stuff. But for the most part, you could send your manager a layout of something you're going to build, and if you lock down all the motion points and stuff, they can sit there and go and, like, you know, click on the propeller and it spins. Yeah. Fusion 360 is cool. I have a full student version. Yeah, it's a good version to have. I got the educational version because I'm teaching you guys, right? I'm teaching you guys the educational license. But they did change stuff with the permissions of the free tier. So people created scripts for you to take all of your 3D files out of the software successfully because it's a little convoluted to do. And all my stuff is so disorganized. I need to reorganize everything and then spend a week doing this, figuring out how the fuck I do this. Because that was weird. I right-clicked on something and then it took me to the right thing. Do you want to finish the package and add it to the library? Yeah, I want to finish that package. Yeah. What do you mean close? Yeah, save it. Sure, user saved. Jesus Christ. Devices. It still doesn't have the right model. What the fuck did I just do then? What did I just do? Is there a different one? Do I need to, like, close it? Do I need to upload it to the cloud? Manage. Give it to the cloud. Boggles my brain they don't sell a $10 to $15 a month advanced hobbyist plan. I would absolutely get that plan if that existed. Yeah. Even if it was like a $30 to $50, maybe 50 might be a little bit much, but like a $30 a month, $10 to $15 a month adds up, you know, 15 times 12. That would be pretty. I mean, 15, what is math? Calculator. I can't believe I have to do this. I could have used 10. It would have been an easier number, but this is like good third grade math. $180 a year is about half of what they charge. I think it's like 300 something a year, 380, 40 or something like that. But yeah, like a half of that price, I would be tempted to abandon the educational license, because if I'm talking about this stuff with you guys from a hobby perspective, while I am teaching, it also gives me more room than the people using the hobbyist version. $4.95, not on sale. Ugh. So it is like $40 a month. Ugh. Yeah, if I do better at streaming, and people actually like watch all the stupid shenanigans that I get up to here, then I would consider buying, actually buying it. But yeah, that is a bit of an oof. What is the software doing right now? It appears to be freezing. Okay, you eventually figured it out. Hey, there it is. When did that happen? I guess when I uploaded to the cloud, everything got its shit together. Yeah. Okay. That was it. Look at how easy it was to create a part. God, they need a better flow for this. They need to figure out why is this still slow? What's going on? What are you doing? There's so much stuff open right now that I think it's starting to struggle a little bit. I was running into this yesterday. But like, they really desperately need a better flow for this. It's very difficult to get a library of good 3D rendered components, but it's becoming more and more the standard, right? You're able to some manufacturers are releasing footprint and device libraries for their parts. I love that. I would love it if that was the standard, because they make those three-dimensional drawings. They make those, they tell you what hole layouts to use. They should partially be responsible for creating this part in a library. And then I would be able to go to the manufacturer Hyros, and I'd be able to select whatever part I wanted, put that into the software, have it 3D rendered, beautiful, ready to go, design around it, easy peasy. Suddenly I'm buying connectors from Hyros, right? That is the best version of this. But in the meantime, we need a better flow for adding our own parts to this, because you can't be expected to have a three-dimensional render of every single part available. So you spend a little bit of time creating your model. How do you get that into a part? What if the part already exists? What's the flow for that? What we just saw was just me randomly clicking shit and eventually coming to the right conclusion, because I know what windows in Fusion are red flags. The one that I really want is the view of this thing with this overlaid onto the sketch. So I know where the holes are that I need to mount this thing to. Oh, God. What a... Thanks for coming to my TED Talk, everybody. Jesus fucking Christ. And then at the end of it, it didn't even show me the three-dimensional part until I uploaded it to the cloud. So there's a couple little things here that tweak that I would really appreciate. Hobby version only allows 10 projects open. But part of those projects are components, right? Do you only get 10 components? You have to archive the old ones, and I need to figure out where the archive is too. Shut up, Short Lurker. Short Lurker's better at Fusion 360 than I am. Demonstrably better. Okay, so I finished that component. I never want to go back to the library manager again. By the way, the super duper trick was to right click on this part of the tree and then do either create new 3D model or attach a copy of existing 3D model. That tool, that dialog box, doesn't exist anywhere else. Isn't that fun? We're all connected? Yeah, okay, everything's connected. Okay, so that finishes that little adventure. We'll save it, user saved and all that. Now I can go back to my schematic. Oh, and also electronic parts are not limited in that 10 project thing. No need to archive, just set to read only so you can edit other files. Yeah, and then version milestoning is not part of the free license. So you don't milestone stuff, you archive it, or sorry, you read only the file. So you finish your project and read only it. And then you can unread only it. See, in my version, I have milestones. So if I want a drawing or like a 3D design that doesn't have any of this history on it, and it's locked down to that history, I will milestone it. And if I need to go back, I can edit it from that milestone. So I could probably get away with milestoning it right at the point where I try to incorporate that other PCB onto this. That's not what I've done. When I go back and do the final edition of the PCB, I will go back to the steps where I'm actually importing all the stuff. And then I've collapsed those into trees of the various things that I've built, like the servo plate, which still needs to be altered. So I need to go back in history and edit them in place. Sadria, thank you for following. The free limitation is an inconvenience and just really annoying. It doesn't limit functionality dramatically. If I have a part that I've archived, like a screw, is that going to count towards my 10? Like, do I have to archive screws and then pull them in? See, I don't know these things. Like the wheels, the specific wheels and not the template wheel project, I would have to keep. The template for the wheels would have to be one of the 10 projects, and then the Volvo R copy that I did would have to be archived. But could I still use it as a component in a work in progress like this? I think the answer is yes, but I just wanted to ask that. And then when I pull in somebody else's component, what do I do with that? I mean, that's not a work in progress, so I'd probably have to limit it. SolidWorks education through the Experimental Aircraft Association is far more feature-rich for the home engineer. That's what I'm using. I'm using the educational copy. I may have not been totally truthful in a couple places about what institution I'm with, but I am sitting here using it for educational purposes with you guys, and I'm not making money off of the software itself. I haven't sold anything that I've designed on stream at all, and I've freely given to you, upon request, I've given you guys the files that you need in order to run these, all this stuff that I've done. Okay, it can be set read-only, and then you can insert it into your current project without it working against the 10 project limit. See, if my educational license gets revoked, I'm not going to shed too many tears because, I mean, let's be honest. It's probably fine if I don't have an educational license, but it also means that I'll be able to teach you guys the software within those limitations under free version restrictions. I think that would be a decent enough thing. You know, that would probably be good. It's just, you know, dealing with archiving stuff. Not archiving, read-onlying stuff. It's sad that the educational license isn't like the base that everybody can use, but I guess they wanted to deal with like data storage and people, you know, maybe storing too many really bad designs. I've been learning how to use this software better and better though, and to be fair, like when you're doing individual operations on a design like this, it's really cool to be able to have like, well, I'm just gonna do this. It's really cool to be able to be like, Giganix, thank you for following. To be able to be like, here are all the steps of me importing all the stuff that needs to go together in order to create the model kit. If I need to edit any of the stuff, I will need to go to the individual files for all the stuff. Once I got the stuff in, I locked it all in place. Once it was all locked in place, I needed to create a couple 3D extrusions in order to mount the servo and the main motor. So I have one section where the only thing that I'm doing is creating the base plate for the servo. The next logical section, obviously, I am creating... Why did it highlight everything? I'm creating the top plate for the servo. It's so slow. The top plate for the servo. Next, I'm creating the ring to mount the motor. And then from there, I create the front of the motor. And then this is the cosmetic chamfer on the motor. So yeah. What do you think of people that use software license loopholes like developers that use the non-pro version of Unity, and when they actually release the game on Steam, they just paid $20 to compile it with the pro license and cancel their subscription? Is that what people do? I don't know how the licensing works for these things. Unity, like the Unity engine is, I think, a wonderful thing because so many just inane ideas for games have been able to come to fruition. And you get like the jankiest things you've ever seen. Yeah, I don't know. I cheat. Okay, let's see how Baloo cheats. I put all my parts into one project. Then if I need a part, I save a copy and import it into the new project. How does that work? Wait a minute. All your parts into one project. Oh, I see. You have all the individual like components in one big drawing. And then you copy that drawing and pull it into the new one. That's another way to do it. I mean, Fusion allows you to have different bodies. And so one thing I did was this screw originated from a 3mm version of that screw, and it turns out that both of them were being moved into the drawing. But yeah, apparently that's something you can do too. I'm getting heartburn from fast food. I shouldn't have had fast food for lunch. Ever. All right, so now we've got our component in there. We can take the latest version of the PCB and check it out. I'm going to rearrange some stuff to kind of pack it all in and give it somewhat of a logical layout, not a fully vetted layout, right? I hope they like my bad unfinished designs. Yeah, exactly. All the weird shit that I've built. Sounds like a bad business plan. I am thankful that Fusion is smart enough to embrace the hobby community, because that's essentially what Eagle was. Eagle was like I think it was like $30 a year or something like that. It was, you know, you could pay for it per year for relatively cheap, and you would have very comprehensive PCB layout software. Incorporating that entire ecosystem into very comprehensive three-dimensional design software is just the chef's kiss, right? That brings us, as a hobbyist, that brings us all into the 21st century, like immediately. I think that is a wonderful move. If you do this stuff using free software, you have to use a bunch of different free softwares, but they all work together. But these kind of are all incorporated into one another. So it's wonderful to have. They don't have to have, you know, a free license level. Although, you know, it's to get people to pay for your software, it would really help to give them experience in it first. So, but yeah, I don't know. It is what it is. I can't, yeah. They dropped Eagle's Linux support when they brought it in Fusion, did they? That sucks. I really wish Fusion did have Linux support. That would be very nice to have. Very, very nice to have. All right, so I need to drop my component. You do that in the schematic. So I'm going to go and I'm going to drop a component. And now, in my connection... Oh, God, I fucking hate that I have two of these. One of these is the local one, and the other one is the managed one from the cloud. I need to get rid of one of them. I don't know which one is which. That one has Hyros in it. Oh, that's components versus connectors. This one versus this one. They both have Hyros in it. Oh, I see. So that's... Well, now I know which one's which. Jeez. I don't want to copy the urn. Yeah, they need to work on this a little bit. Okay, so here's our component, right? We can see that we have a symbol, we have a footprint, and then we have a three-dimensional drawing of it. Pretty cool. So click OK. And now it is facing the wrong direction. Dun, dun, dun. Depending on which pin I want to be what. I think I want pin 1 to be ground, maybe. So I'll just center click the mouse, and then I'll flip it. It'll horizontally mirror it. I can right click the mouse to rotate it 180 degrees, but I'll just, see right there, that would mean that pin 1 is ground. And then that would mean pin 3 is ground. And pin 1 is the... Actually, that is how I want it. All right, never mind. So I'll just do it like that. Oh, wow. What an elegant name that totally fits in a minimal... Oh, God. Why does it do this? P1, P2, P3. That should not be... I guess those are the signal names, but those should really be just 1, 2, and 3. That's really annoying. Okay, anyway. And then it comes up as U7? What the fuck? All right. So we messed up a couple things in the naming of this. I think this is the part that we put down. Probably could have had some better labeling on it. We can go in and fix that later. But either way, what I'm going to do is I'm going to use their button to get over to the next drawing. So the next drawing is the PCB layout. Use their button. That way all the references update. Theoretically. Theoretically. Okay. So if you're not going to update... Well, it did. Okay. So yeah, there's that. Oh yeah, the 2D and 3D are out of sync. All right, that doesn't bother me much. So yeah, here's our connector. We just have to locate it somewhere on this board now. Now I'm still in the early parts of the layout and figuring out what exactly goes where. I've added the screw holes, and now I've got the 3-pin connector for the servo. That's getting a little close. I want to make sure that I leave... See, the thing is the motor is right here. The motor's right here, and that would probably be a bad location for something like the servo connector. So I think what I need to do... Now, those pads are on the underside. So I could technically... Well, those pads are going to get in the way of these connections. And I could move that inboard a little bit more. Let's keep it right there and just see what happens. We'll keep it right there just for the sake of display. And let me move in some of the other components that I was trying to, like, arrange and just kind of figure out what the layout would be. Basically, what I'm doing is with the air wires, the wires that are going from point to point on the connection that I programmed using the schematic in the schematic drawing programs those air wires. I will then need to come back by hand and lay them out. You can use auto routing softwares too. I would love a topor routing program, but I don't know what the final layout of the schematic is yet. But there are certain things that I can put in certain places to kind of give them positioning. But routing by hand I've found to be the best way to do things. Okay, you know what? I think these resistors I'm gonna have to drop down to the bottom layer. Those are the pull-ups and downs for the transistors. They're just kind of in the way. I don't have a lot of room. And I've got to put this entire layout somewhere, as well as the entire microcontroller, which I could put on the underside, but I can't do it over here. It would have to be like there, or if I just put it, I mean, there it's pretty good. That limits our connections to the outside world, but let's see. That one would be the capacitor. The capacitor. Let's just get this stuff down. This is not going to be the final layout by any means. I'll have to come back and like rearrange stuff because yeah, this is going to be, some spots are going to be very difficult to get components into. And then these transistors are going to need to be surrounded by a lot of copper, so they can bleed off all of their excess heat. May need to also add extra filtering devices because of the noise of the motor. We've still got to figure out how to solve that. I use auto routing in KiCad, then clean it up by hand to remove things like acid traps. Interesting. I didn't think acid traps were an issue anymore with circuit boards. Those pads are going to be right on top of one another, aren't they? And I really should have that capacitor right there. Can you please stop? Why would I want to grab the air wire ever, AutoCAD? Why? I don't want the air wire. Okay. One thing I do wish I could have is sketch lines on this layer. If I could have sketch lines on this layer, I would know what 4 millimeters is from that screw head. I'll have to incorporate some layout tools later. Try to get structures designed around this stuff. One component, huh? Nice and close. This is literally just to figure out where stuff should go. The whole purpose of this is not to finalize the layout by any means. We're just trying to get a mechanical sense of where things are. That can go into there because these are just connections to the radio above it. Those can be squished into a little bit. All right, so from there, I mean, I've just like haphazardly thrown things onto the board, right? I need to move around a whole bunch of the stuff, right? But all this is there to do is to give me a sense of where this is going. So let's update the three-dimensional PCB. I'll get fancier when I actually start to settle on a layout. Boop, boop, boop. Here we go. Here we go. Here we go. Okay, it's still thinking. It's working. It's doing its best. Oh my god. There's all the components. Haven't rendered in yet. Here they come. Bam! All right. Now we get a sense. I know, next slide. Seconds per frame. So now we have a sense of what all this stuff looks like on the board, at least approximately. So underneath, we've got a bunch of components. I could probably do more underneath the board. I could probably add some more underneath the board. I put the LEDs under there too. I figure there will be enough standoff that we'll have room for all of these components. And then on the top, we've got our wonderful connector that we just created. Is that too close? Uh-oh. Why slow? Why slow? Yeah, I think that's clipping in a little bit. Might need to be a little bit taller. Well, I can see. Yeah, it's clipping into the silk screen. They gave the silk screen depth. The silk screen has depth, and so, yeah. I love this view, but the silk screen needs some work. Listen, fuck you, chat. Go fuck yourself. This is the initial layout. We're not doing... Silkscreen is the last thing you work on with this stuff. I'm sorry it's not perfect right out of the box. Jesus fucking Christ. The whole point of doing this is to figure out all the other facets of the drawing, and I haven't even figured out where components are going to sit yet. Man. The very last thing you work on is the silkscreen. Because yeah, this is not acceptable. That capacitor's in the wrong spot. This is great, but that capacitor, you put it in the wrong spot. It's like, geez, it took 2 minutes to throw parts on a board. It'll be okay. These pads aren't as shiny as I think they should be, and I don't know why that is. I think it's a layer coloring issue. Those should be shiny. But yeah, those pads are going to need extensive labeling, because 2 of them are the motor input, and then the other 2 are power input. You definitely could have been talking about the software, not you. That's just, okay, if I got that wrong, I'm sorry. I'm too sensitive. I mean, I think the silkscreen is properly represented. It's just a little haphazard right now because all that stuff needs better labeling and stuff like that. What I do is the very last thing I do is I turn off values and then I make them all the same size labelings and then put them into the right spots and make sure that they're given logical names, right? That's like the last thing that I do. And you know, readable names where they're not placed on top of other stuff. But we're not worried about that right now. What we're worried about is me hitting Control S on this. User saved. Let that go into there. That's going to update my assembly. And then that assembly is what goes into the work in progress frame as a component. So right now, I'm going to get an error about this thing not being updated. If I get the latest version, the changes will propagate through the entire thing. And now, why is there's like a little triangle on that? What's going on there? I wonder what that little arrow is. I don't know what that is. But now that entire circuit board has now been placed inside of the drawing. And since I changed the dimensions, this is no longer clipping in. And all our stuff. Oh, look, the pads aren't on. Where are the pads? What's going on with that? Where are my pads? What the fuck? How come they're not in this one and they're in the other one? Interesting. Got some issues here. Are the outer dimensions? Wait, that's upside down. Oh, this is a different version entirely. Wait a minute, this is not the latest version. This is not my beautiful wife. Huh. I guess I need to do it again. Update external references. I guess it went one version up or something. There we go. Now we've got our connector. Oh, it looks like it's clipping into that. Well, that's misplaced. That's the problem. Let me go back to the component, the assembly rather. Miguel Oz. Hey, Miguel Oz, how you doing? 17 months. Yeah, the traces will exist when I do the connections. I haven't done the connections yet. Look at all these. Look at all these. God damn it. I have 3 of the same part. Oh my god. What was I going to go into? I wanted to go into the assembly of the circuit boards, which is not in this folder. Oh, the board's moving. Hold on. Miguel Oz, putting you up into the board. Thank you so much for subbing. For 17 months. Oh my god. It looks hot out. Looks like a disaster outside. And we're walking, and we're walking. Really? Going all the way over here, huh? Jesus. No, stop it. I don't want to position the camera for the... okay, fine. I gotta move that box off of the corner of the table. Mikel Oz, you're up by Dildo Bazooka. Welcome to the board. You're destroying Max Headroom. This thing is going on the long journey home after crossing the entire board. All right. Back to Fusion. Back to Fusion. What'll I come up with next? So, yeah, the schematic parts that represent the gyroscope and represent the radio are not given these 3D boards. These 3D boards I generated on my own very quickly in order to create something to go on top to give me an impression of what would be in that area. So I need to rearrange them on the main PCB, which is an assembly. So the assembly is here in the DOS Redux folder, and that would be this one, small DOS assembly. And that's how I keep it organized. That's why I don't have 3 separate components that I need to move around. One component is out of date. Oh my God. Update the external references. Ba-bam. Fusion team error message. I love how that came up for like a split second. You're adding this design in another tab. You can only save changes in that one tab at a time. If you save changes in this tab, you may lose your changes in the other tab. What the fuck are you talking about? Wait, how many? Okay. Small DOS assembly. No. I guess they think that I'll do something to the PCB with this. But anyway, I want to move this component. And actually, it would be useful if we did a top orthographic view so that I can match up the holes. Yeah, see that? I didn't really figure out exactly where those holes should go. It's more the outline that's important. Yeah, so that's about there. See that I need to measure this thing and figure out where those holes exactly are, just so that I can work on it properly. I keep those holes in the other one just because it I can use straight pieces of wire to connect the gyro. Components, this thing, I want to move it down. Uh, 0.6. .8. Yep. Orthographic just lets me be right on top of these lines. Come on. Yeah, all the fusion things where you can like project a line through one thing onto another drawing and then draw from there. I wish those existed for this kind of stuff, because that would be very powerful for me to be able to manipulate these things properly with less hullabaloo. All right, so I'm going to move these down. And again, the reason that I'm doing this today is because this is what I would be doing anyway with my day. I can go a little lower than that, right? Yeah, that's probably pretty good. Move copy. Move the component. And we select dish guy, and I move him down. Bonk. Move him a little bit above bonk. Although maybe I want that to be a little taller because I'm going to be using VHB tape to hold that thing in place. There's no like solid connection. I put holes. I put through holes on this just to represent the pins of this thing. It actually just has pads. There are 3 holes, but then all these are pads. But again, it doesn't need to be exactly the same thing. It just needs to be close enough that I can start to design around it. One of my thoughts was, well, what if I create a 3D printed frame that holds these 2 devices up? That's for another day. Oh, everything looks weird because it's in orthographic mode. Bonk. There we go. But yeah, so that's okay. So I'm gonna save that, and then that'll propagate over to the big drawing. Sephiru, thank you for following. Did I close the right one? I think I did. Back to here. Now all my references explode. I get to update it again. Update the external reference. Yeah, discard the changes and update. There's an order of operations that I think I am violating in some of the areas of this thing. Are you updating or not? What's going on here? It doesn't feel like you've updated. Excuse me? Did it not? Ah, boy. Did it not take any of that in? Is this, what's going on here? I guess it misinterpreted all that stuff. Let's see if this one's updated then. Yeah, that one's saved and updated properly. Standard operating procedures equals order of operations. First, make sure you're wearing pants or equivalent. Yeah. Standard operating procedure of order operation, order operating orders. Curses. Okay, so yeah, it got confused. So, I mean, what I can do is just get rid of the step where I import it. And then bring it back in, I guess. I never had to do that before, but here we are. Oh, that was the free move. Ugh. Be careful of that one. That's a dangerous one. Yeah, because it's like all discombobulated. Where? What the? Okay. Top. Let's go ortho. I'm running out of room to work here. Jeez. Bring it in over here. Let's go to the side view. Bring it up till the electronics are pretty close. Yeah, I got to keep those boards under the top rail. Wow, that is just about the size. Man, that's interesting. Oh, the boards are still floating up in space. What's that all about? And that one's still clipping in. What the devil? All right, Control Z. You get out of here, new part. I see you hiding over there. Control Z you until you're gone. Control S. User saved. What's going on with this? The stuff isn't updating properly. That one's fine. This one's the assembly, and it's saved. Control S. Save it again. Maybe because I didn't capture the position in here? Maybe that'll do it. That's probably, maybe that's it. I don't know. I'm not sure. So that should be tighter. Go back to the original drawing. This is the way it should work. I just don't know why it's it's getting all discombobulated. That's the overall electronics design. Schematic, PCB. This would be the 3D render, which needs a different name. Yeah, that should have a different name, but it doesn't. I'll have to correct that later. So if I take that and I go to the folder and I go to the assembly, which we updated, I should be able to just drag this thing in and it should just update itself. I don't know what this is. That one's left over. Which one did we get? Okay, this is the one with the appropriate distances. Jeez, I don't know what's going on there. I think locking all the stuff in place is the important step that I didn't do. So we're still in orthographic perspective, which gives us this wonderful little like drawing layout, and we can figure out precisely where stuff should go, even in just, you know, haphazardly fitting things together. Yeah, see, I think the problem with that connector's location is that it's going to be interfered with by the motor ring. Motoring, get it? All right, there's that. Is that a good spot? I think that's a good spot. Maybe it won't be as interfered. If I keep it inboard like that, we might have room for the connector. The front of the servo saver is a problem, because there might be a bolt sticking in there. I'd love to give it all the room that it needs, but getting real close. Of course, I got to move the blue LED. This is why we're doing this. Is this layout kind of thing helps to give me an idea of where everything sits. And I'll do two little screw posts out of this piece. Out of the Y piece, I'll make two little screw posts, and that will hold up the rest of the stuff. But yeah, getting those LEDs in the right spot is important, because those dictate how you calibrate the motor controller and stuff when you calibrate it. All right, so that's sort of what I wanted to get out of this, is like, where are my connections going to be, and what's that going to look like? And, you know, having those pads there, that means that two wires, probably the motor wires, are going to come in and connect up here, and then I have two more wires that need to go to the battery, and those could actually be over here if they need to be. They could be on the back side of it, although it probably is more convenient. I've got this big tunnel here, and I could run some wires in that won't hit the drive shaft. Needless to say, I could always do a little, if it becomes an issue, I could do a little arm coming off of this piece that holds up those wires and keeps them out of the way. But yeah, the motor wires can come down across the motor, do 180 degrees, and then connect to those pads, and then I'll have other wires that come out to the front of the same gauge and go to the switch, basically to the switch, and then the switch will have the battery connector on it, and all that nonsense can stuff right here in front of the battery. I hate to have it stuff in like that, but I mean, that's just the logical way to do it, because I don't have room for a switch on this thing. If I have the motor wires going back and around, then that gives me something to suspend the wires on. Plus there's this trough here that I could use to do like a little zip tie. Or I could 3D print something that screws into here and has a little wire nut on it. That would be the cleanest way to do it, is to do just a very shallow screw that holds up just a little wire loop. That may be what I end up doing. Nope, not what I wanted to do. It's been a really cool project to follow. I'm glad, because I mean, it's a little selfish, right? It's a little shellfish, because it's really just my project. Like I'm not selling it or anything. This is a wltoys kit, but I'm showing how engineering things get. How you can take a look at something and go, I don't like the way that is. I'm gonna change it. And if you put in the effort, yeah, of course the blue LED is gonna move. Of course it's gonna move. It's not even gonna be that type of LED when I'm done. The blue LED is gonna have to move. I may keep this height, this board height, and provide standoffs from that. I will need to import this device at an earlier stage. I like watching real CAD usage, designing 3D parts on real objects. Hell yeah. What's the name of that kit? It's the wltoys 989, and it's nothing like this when you start out. I mean, it's almost better to get like a mini Z just right off the bat at the size that you want. I need a haircut, don't I? Jesus Christ, what am I going to do that? Maybe that's my weekend plans, is to get a haircut. Yeah, this is the wltoys 989 kit. It's nothing like this when you first get it. There are spare parts kits what include metal A-arms and spindles, because those are part of the parts that are just going to break immediately on the kit. The A-arms and the spindles are stuff that breaks very easily. So $20 and you get the inability to focus on this thing. $20 and you get the spindles and the A-arms and stuff. I had to source ball joints so I could do the steering linkages, and then I had to source specific suspension stuff so I didn't get shitty suspension pieces, because the ones that I got in the mail that were of this metal kit were terrible. These were another like 20-something dollars. The truck wheels. The slightly elongated axles were also from like a truck, or from another $20 from another store. And the slightly elongated axles are necessary because these A-arms are a little bit larger than the original ones. Found another kit on eBay. If you look up DIY Mini D RC car, it's more close to this, what I'm producing, yeah. Because, yeah, those A-arms were a little flimsy and they broke. And then I replaced the pan with just whatever carbon fiber pan I could find. The motor and the motor controller stuff, I don't know if I can recommend anybody go down the path that I have of downgrading the motor to a 130 type, because it's harder to find a motor controller for a 1-cell battery. It's harder to find a motor controller that can handle the current. That's kind of what I'm building here. That's why this is such a weird part of the project. Like most things that I do, it's just kind of become a mutant over time. We're happy with mutants here. We like mutants. So I kind of want to keep those pads there, right? I kind of want to keep those pads there. The servo connector, I can't do much with. I've got 1, 2, 3, 4, right? I've got 4 pads, 2 pads on the top, 2 pads on the bottom. That servo connector is just there. The only thing that I could really do with it is move it in a little bit further. It's a good size. At least the size is good. But it's going to be tough to get the wires to do a little 180 down to the servo down there. Now the high rows crimp cleanly. I can crimp that really easily. And those are the motor controller MOSFETs. Jesus, this thing's tight. Now I haven't fully utilized the bottom of the board yet, right? I think as I put the circuit structures together, I can move more stuff to the bottom of the board. Presumably, I can move this back a little bit into the inboard. Maybe I can put 2 MOSFETs on top, 2 on bottom. I'm not sure. Will there be enough clearance from connecting something to the connector? Barely. Yeah, barely. That'll barely fit. I think that's pretty good, though. That's why we do this in CAD. It's going to be an absolute beast to unplug. You'll have to unscrew the circuit board in order to unplug it. But I mean, if you're doing that with the servo, you're going to have to be getting into there anyway. So might be a little too much. I could probably move it down a little bit if I need to. I'm not putting the microcontroller under there. I'll just have to be cautious. See, I wish I could actually mark. Oops, I don't need anything filleted. I wish I could mark the locations of these screws, because, like, see that? I got a transistor clipping into a screw. This is not a problem I expected to have. My transistors are clipping into my screws. But yeah, from here, I can create the posts that I need in order to mount the PCB. I did 2 screws. I think that'll be enough if I give the post enough width, because I'll be using these panhead screws. So if I put a 3mm panhead through there, I should have enough space. I mean, let's check it out. Let's see what that looks like with the panheads on it. RC cars, screws, M2 3mm. You go here. I'm gonna need 2 of these, but I'll do a move copy on it. So this is just, right now I'm just experimenting. If I were actually seriously adding this stuff to the drawing, I would have it so that I add this stuff back here before I lock the positions down. so that the timeline is preserved. Point to point. Choose that radius there. We're moving it to this radius here. Oops, I meant to move copy. All right, well, we'll just move copy it again. No, why are you slow? What's going on? Stop it. Fusion? Okay. That should be enough for it to bite in. I could use a longer one. Move copy, components, we'll start with this one, create a copy. I'll just drag you out. And then I'll give you a point to point. From here to here. Okay. And the post is going to be the same size going to that. But yeah, that's essentially what's going to be holding the circuit board in place. Hopefully that keeps it from vibrating, because I think vibration is going to make the gyro go crazy. I can't wait to get this together, though, to have the gyro and the motor controller on there, having everything work properly. We need to figure out what other circuit elements I need in order to stabilize the motor controller. If I need a big capacitor, there's only room for it, like, right here. Or if I move these to the side, I still don't get room for it. Or if I toss the capacitor, like, down here. I mean, I could maybe do some slightly larger components in this area near the drive shaft. It would actually be kind of funny if I was able to get, like, a speed readout from this drive shaft, like, through some kind of a component nearby. But I don't think there's all that much room. There really just isn't. So yeah, if I need extra, like, Zener diodes and stuff like that, this is right around where the motor connects. So power and motor are coming in basically on top of one another. So they would be in this area, and I've got a little bit of excess space there. Whew, man, it's tight. The drive shaft steel. It might be stainless. I think it is. No, maybe just chromed. Yeah, it's not stainless. Is it mild or is it magnetic? Hold on, let's check it out. I'm gonna see. I think this is a magnet. Enough of a magnet? No, it's not much of a magnet. Yeah, it's mild steel, I think. I haven't seen rust on it, so I don't know. Does that look weird? Oh, because we're looking inside of the shaft. Oh, I get it. Yeah, there's some weirdnesses in the model too. Like this clearance is not, that's not quite right. But oh well. I'm not modeling the differential. If I had the ability to print plastics that small, I would love to do a torsion diff. Yeah, I could glue a little mirror to it. Not even a mirror, just a reflective dot. Or just a magic marker marking, and sense that with something optical. It's a good idea, but I'm not going to do it because the motor controller doesn't need to know, unless I do like traction sensing. That would be great if I had access to the accelerometer and a speed indicator. So accelerometer and speed indicator to do like a traction control system. This is too small of an RC car to do that kind of stuff with. If I was doing a normal scale RC car, I would have loved to incorporate the servo system on the 4 posts. So you've got your springs, but then you've also got servos that raise and lower them, and it makes the car like tilt and rock as if it's a full scale car. Really cool system. We were looking at that the other day. It looks like it does a lot of cool stuff for the model. I could probably also eke out just a little bit more space if I got these closer to the edge. The other thing is whether or not components from these will interfere with that screw. Which just means that I would mount that a little higher up, so that's fine. Yeah, those could just mount a little bit taller than they are right now. Cool. Well, all right. So I'm a little bit more confident in the PCB size that I selected. I can fit all the parts. Now, the arrangement of the parts is going to change depending on what I can do routing-wise. I've still got a little bit of extra space under the board. I think the next step with this, aside from me endlessly rearranging the parts on a small scale, like maybe I can move this over just a little bit more, or maybe I could put this just over here. Do that until I'm blue in the face. But the point is, what I need to do next is figure out how in the hell we can filter the signal, filter out the noise that this giant motor is going to cause. I mean, it really is a very, very large, actually it's very small. It's a very small motor. It's a 130 size motor. It's very common in you know, little battery operated cars and stuff, because the Mia knows what they're doing. They're really cool motors. The one I have in this kit is a Light Dash. The Light Dash is okay. The one that I have sitting here is the Plasma Dash, which is like the granddaddy of all these motors. This thing is like the badass grandma of all these other motors. This thing will fuck you up. It's banned in some competitions. What I've got over here is, I believe it's a Power Dash, and I had to, no, it is a, whatever the green one is. I forget what the green one is, but it's in a Power Dash shell, because that's the one that I drilled the front out of. So now that I don't need to drill out the front, I can swap motors all day, every day with a soldering iron. But it creates some noise because these things have that much more power running through them. They've got big, thick wires on the spindle. The one I grenaded has big, thick wires. And they've got big, thick wires on the spindle, possibly brushes. When you go all out with these things, something about the way that they connect with those brushes causes some kind of a disruption in the power and resets everything. Since I'm using a generic radio unit, this thing matches up with whatever is around when it powers up. So this will match with my remote very easily, I might add, but it'll also match with anybody else's remote too. But because of that, it takes a little while to start up. So that little spike in energy kills all of your electronics for a period of time. Same with my motor controller, also takes a second to spark up and start functioning. So we need to solve that noise issue. I've got everything laid out on the perforated prototyping board. When we pick this up again, after I've had a little time to mess with this drawing a little bit more, when we pick this up again, we'll be breadboarding, and I'll have more strategies to try to solve the noise issues, including, but not limited to, Zener diodes and capacitors. If I need to add a big capacitor to this, I don't know where I'm going to do it. I just don't know where I'm going to do it. There's just not space. There's space for like mid-sized capacitors. I might be able to sneak in a couple little mid-sized capacitors, but other than that, not sure. Not really sure. Yeah, it would be hilarious to do like traction control on this. Just a limited slip. Do ABS. Actually, ABS is in the controller, but that's going to be, this thing is going to be difficult to plug in. You're not running the car on super caps. I do have super caps, but in order to create any substantial voltage with it, man. Throw all the caps between the battery and the thing. Good Lord. You need some filtering between your motor controlling stuff and the electronics running everything. So I would have to determine where that filtration is, or how to implement it properly. The other thing is, like, the motor cap is, well, actually it's better now because I'm not using connectors anymore. If I really wanted to, I could probably fit maybe miniature banana connectors on these pads, but probably not the best idea. I can't put vias under those pads because the other pads are right below them too. That's going to be tough from a layout standpoint. So to keep those pads strong, what I'm going to need to do is pop a via in it. But there's a pad directly under it of the same type. That's going to be a tough one. Yeah, I could rotate the connector 180 degrees for more clearance, but I mean, I don't really need to. I don't really need to. I think this will be okay. We've got plenty of room for the plastic connector. I mean, here. So from this to this. Or no, it was all the way to the back, was it? Here. With a connector plugged in. Where'd that part of the drawing go? Didn't we have the... Oh, here it is. 6.4. I need to find like an actual point. Well, I guess I could do this to this. Oh, I'm gonna cough. So 6.4, we have 6.9, and then the cables for this are going to come out and barely miss. So it'll be tight, but it'll fit. Push comes to shove, I could extend the circuit board out by a little bit, and then that would move the connector a little bit to the left. I might extend the circuit board out just because I need all the space that I can get on the damn thing. Although I do have a lot of room under the modules, so maybe I can make it work. I think I can make it work. Oh my god. It's crazy, right? But I think we can make it work. All right. If you guys didn't notice, I'm kind of out of stuff to do now. I'm out of stuff to do that isn't like PCB layout hardcore stuff that I don't really want to do on camera. We're going to come back tomorrow, and I have a shitload of stuff. Like, I got a shitload of stuff to do, guys. All on stream. On Friday, we have a thing that the other Lone Star sent in. We still have the stuff that Groovy sent in, too. Groovy something sent me a bunch of little RC car stuff, which will be really fun to take apart. Like old radio stuff. Old radio RC car stuff. I got to get a haircut. And then the computer project, which is still going, with like basic assembly and just figuring out what the next parts are, because I know how to design all of the parts that'll hold up the gratings in AutoCAD. We can figure out where to put the hard drive and how I can make a mount for that. And that all brings us into 3D design, but physical 3D design, which is so much easier than doing this circuit board nonsense. You guys got to see a little bit of the frustration that I have in the process flow of getting a component from the internet and then putting it into your design. It's convoluted. It needs help. It's one of those sections of Fusion where I think the people they have working on it are so ingrained. They've been working on it for so long that they have blinders on and they may not see sort of how convoluted it is. They go, this is perfectly logical, and it's not. It's just not. So, all right. Yeah. 4 hours. I really didn't want to end it so soon, but all I have left to do is just lovingly stare at a Fusion 360 model and like barely arrange stuff around in it in order to get to a conclusion that I shouldn't be at this point. I should probably finish that electronics design, but I need to do homework. I need to look up H-bridge motor control filter circuits, or you know, and other stuff like that. I need to do a little bit of perusing of the internet to figure it out. Oh, thanks, yes, Body Me. I appreciate that, man. I know, Torsen Diff design time. Don't you dare. Don't you dare tempt me. I want to get springs into this, but I haven't been able... I found like a 3D printed springs file, and if I scale them down, they'll look ridiculous, but they could still fit in the area and be a little believable. And then I would love to redo the diff housing so that it was a little bit more accurate, but I need to rearrange the order of operations that everything's happening in that model, because I've only recently discovered that I can make these categories for the timeline in order to simplify it. Should have did that with this. You can take raw filament and wrap it around the cylinder and bake it to make decent spring. I'm not doing that. I'm not doing that. No, I'm not making my own springs. I had to buy a bunch of terrible springs in order to find these good ones. Yeah, it's easier to just get real springs, and if you know how to size your springs and everything, you can get good stuff. But these were slightly different metal springs for the wltoys kit, and they do so much better. They're so much better. Because the ones that came with this metal stuff, they had a threaded cylinder as the shock body, but this one is threaded on the outside. The other one was threaded on the inside. So whenever you put pressure on it from a slightly bad angle, it would bind up on the threads. It was the dumbest thing I've ever seen. These are not oil filled, nor will they ever be. At this scale, it's like, does that really matter? So yeah, anyway, I mean, hey, now that I've got a model for this thing, part of the fun of having the 3D model for this is now I can go into editing bodies so that I can create a plastic body for this thing that is some kind of weird car. You have the model of some kind of weird car, and I can fully incorporate that into this. What I'm hoping to be able to do is learn how to do the whatever the mesh stuff that AutoCAD does. Actually, the surface tools? Which one is that? It's like... It's like T-splines or something like that is what they call it. Yeah, either way, being able to use some of the more advanced 3D modeling stuff that exists within Fusion. But we got to figure out everything. I got to figure out the electronics first. We're going to get this thing done. I need like a 3D model of the springs. I need a 3D model of the ball joints. I could do motion modeling of this thing so that you could grab a wheel and like do the suspension. How much work is it worth? I don't know. Getting the look right would be neat, but I think this is the minimal amount of componentry in order to get the dimensions of the car right. So oh yeah, the other thing that I want to do is take the chassis plate and grind down these little ears so that they are only a millimeter thick. Because right now they're the thickness of the carbon fiber. They need to be a millimeter, and then I'll get just a little bit more clearance out of the whole thing. Mohammed 007, thank you for following. Hey, I appreciate you guys hanging out with me today. Today was kind of like a hangout and just sort of putz around with stuff. And I know I got a little terse with some of you, but don't worry about it, you know? It's nothing personal. But yeah, a BEC design? I don't know, would a voltage regulator, it wouldn't be a voltage reg, because we're relying on the lithium-ion battery to have a certain range of voltages that are within spec for the AT-Tiny85 to still run. And then when the radio sees the voltage too low, it will stop everything from happening. Like it'll stop doing motor signals and stuff. It'll just park everything. Which is what we want from the model. I've got all the voltage sensing I need in the radio. So how do we do it? I mean, part of it is check valves and capacitors in order to make sure that when that spike occurs, when that negative voltage spike occurs, it will be routed within its local, basically its local ecosystem. And then while that's happening, the capacitors will keep our electronics from dying. That hasn't happened. I put a genuinely large capacitor in there, and we put the Zener diode in order to cater for that. Or no, sorry, it was a Schottky diode in order to cater to that. And we got the reverse voltage, and it took out the whole system. So I don't know. I got to do some research. So if you guys will leave me to that, I'll leave you guys to figure out what you're doing on Twitch from now on. Because I'll be gone forever until tomorrow. I don't think we'll be working on the circuits tomorrow. I would like to have a little bit of time to work on the computer, right? Excited to see what you come up with. Me too. I could raid a video editing stream. Red Dead Redemption. Rob Oz is addicted to Project Zomboid. I don't think he's ever going to play anything else at this rate. Streamers that are bigger than me. Bigfoot. What's Gmart doing? Legends of Runeterra? That sounds weird. Sean is doing PUBG. Really? Really? I thought we were done with that game. Skyrim. People are always playing Skyrim. No matter what. Kit Boga's still going. Tricking tech streamers. How's he doing? Yeah, let's raid Kit Boga. Let's do a Boga raid. We're gonna basically, I'm dropping you guys into a lake of people. So we're gonna do a Boga raid. We'll see. We'll see if anybody notices it even happening. We're like one person entering like a rowdy hall of 10,000 people. So, all right, guys, we'll have fun at Kit Boga. I'm gonna be back tomorrow. Probably gonna be doing computer stuff, and then on Friday we're gonna do the usual, take something apart and try to see how it works. Until then, catch you guys later. Boop. Why are you still looking at me? You shouldn't be able to see me. I already raided. Go watch Kit Boga.